dealing with all these four steps, seeing most important being the research piece. Design comes relatively easily. Okay, to me, design is designing a house, a blueprint, a house, but it's not a house. You got to build it. Okay, and that's where the complexity comes in. So, from my perspective, from outside, I own these two shortcomings in India today. India has everything. Okay, only two. What are they? They're manufacturing expertise, resources, okay, and the infrastructure. Similarly for technologies. So I differentiate between technologies and manufacturing. So clearly, the ISM that you all heard, okay, that you've been hearing about and you heard this morning, okay, takes care of the manufacturing. So I'm not going to talk about that. But however, the technology piece, which is the major piece without which you can't develop next generation of manufacturing technologies, is what I'm going to talk about. And that, okay, if you do it right, okay, then you end up issuing, in my view, okay, the vision for India to be a global hub. So the grand challenge, this is getting to be hard. Can someone push the button maybe? Okay, as you all know, okay, ISM is setting up manufacturing, okay, and you heard this morning, 3 big companies are setting up shop here, right here. Okay, they are Tata, they're CG Power, they're Micron. Okay, if you look at what's happening with those manufacturing technologies, they date back to about 1980 plus or minus. In fact, 2 of those technologies are developed, one is at IBM, the flip chip and organic packaging. So clearly, okay, this is an unbelievable achievement for India. I've been coming to India for 30 years, wanting to help India, not been able to do so, but I'm so happy to see, okay, that India has begun, okay, the journey towards manufacturing. So that's a great first step. And that solves many problems like infrastructure, power, gases, chemicals, all that stuff that takes care of all of that. Now let's ask ourselves, how can we make India from 1980 technologies that's going to manufacture now, how do we bring that to a level where it becomes a global hub? That's what I'm going to talk about. So my view of that is very simple, okay? Quantum computing, okay, every major country, including India, is working on it. Okay, that's far out to me. Well, companies like IBM are doing that. For most part, that's about 20 years away from now in the manufacturing, in my view, and the products. Okay, because first you got to do research, you got to design, and on and on and on. So, okay, the next one, okay, in my view, you know, this is beyond Moore's law. In my view, there are 3 reasons for Moore's law. Okay, doubling the transistor, of course, we all know that, but doubling the transistor always gives 2 other things. It gives rise to increased performance, transistor speed, by about 35%. It also reduces the cost by about half. So, okay, therefore the 3 parameters in Moore's law. Today, if you ask me, is Moore's law valid? In my view, only one of those 3 is valid. We know how to double transistors, but we don't know how to get the speed nor the cost. So for now, I won't go into the details because I don't have the time, but for now, the Moore's law is being saved, in my view, by the next generation of packaging. It's package-enabled Moore's law, giving rise to better performance, better cost, while doing so, okay, doubling the transistors as well. So therefore, we are now coming to an end, in my view, in the research. Leading-edge companies like Intel, okay, are already doing about 18 angstroms. We're no longer in nanometers, we're angstroms. So let's suppose we can bring it down, okay, in the next 5 years to about maybe about 10 angstroms, maybe 8. So it can be 0, okay? So in my view in research, we're not too far away from 0. So therefore, okay, electronic-based computing, okay, will cease, okay, giving us what we need. We need exponential growth in computing power by a factor of 100 to 1,000 to 1,000,000. We can't do that, in my opinion, with the current approach to electronics. So we got to move on in the short term, perhaps photonic-based, better yet, optoelectronic-based, okay, before we go to quantum. Some companies may say, I'm going to skip that, go directly to quantum, that's fine. So that to me is the near term, okay, and the long term. So companies around the globe, including in the US, are working on all these, less than 3 nanometers for semiconductors. Glass packaging, I'm the father of glass packaging, invented that. That is the basis of all the hardware from here on. It's about ultra high density packaging, okay? And the hybrid bonding assembly is no longer solder, so on and on and on. I don't have the time to go into the details, but basically the rest of the world is focusing on developing those technologies, preparing it to manufacture. So my suggestion to India, for it to be a global hub, okay, so first I say there's a grand challenge for India. Going from 1980 manufacturing that India is putting here in Gujarat, okay, to what's going, compared to the rest of the world, okay, like quantum, like photonic-based computing, okay, and on and on and on. So there's about 40-year gap between India's manufacturing and the rest of the world preparing to manufacture. So the best way to do that is basically for India, develop the technologies. So let me tell you what I'm proposing. I'm working with, obviously, with the MIT and ISM folks and all the university folks. My suggestion now is India create, okay, for India to be global hub, this is my recommendation to India, okay, create academic centers for quantum computing. I call it academic, like COEs. But then I say create 12 industry centers in 12 different strategic technologies. I'm going to show you what the 12 are. If you pursue those 12, you can make almost any system, okay? I'll come in a minute. So those 12 industry centers placed at the top IITs, IIC, and other colleges throughout India, if you can do that, the output of that could be integrated towards integrated systems by means of what the ministers have been calling ISRC. It's a technology development place center that takes the advances from the IITs and others, okay, integrates them and prepares those technologies for manufacturing. So if India can follow that, okay, this kind of a scenario, which is what I'm working with, okay, many companies in here and US and elsewhere, and many faculty, some of them are here, and many IITs, I'll show you in a minute. So this is the roadmap. This is, okay, that's simple. Next slide, please. So I see clearly, based on what I've done at Georgia Tech, and I define all the universities over the last 200 years into 3 categories. Universities that produce students, mostly based on classroom, it's a skilled workforce, okay? Most of the top universities in the world have moved on beyond that to what they call research universities. They do research, educate the very best students, okay? Now the third generation of universities, in my view, that's what I pioneered in a small center at Georgia Tech. In my view, it needs to be, next slide please. In my view, it needs to be what I call industry-driven universities, okay? Because the academic research, for most part, does not end up product in the next 20 years. Only about 3% of the product from academic universities goes into products. How do we improve that? By going to what I call third generation. Next slide, please. This is industry-driven research. This is exactly what the 12 centers are. So if India can leapfrog and create these 12 industry-centric centers, okay, it's now ready to prepare itself to be a global hub in all the technologies I talked about, almost like a one-stop shop. Okay, India could be that in my view. Next slide, please. So, but something like this is not going to come easy. It requires transformation the way the government does. It requires a transformation in the way the universities work. It requires a transformation in the way the industry works with the universities and the government. I don't have the time to go into the details, but basically that's what we were working out in India. Okay, all these details, okay, and so next slide, next please. That's what we're asking government to do. This is what we're asking the academics to do, form interdisciplinary teams, okay, prepare for industry-centric centers, okay, work with the industry, and of course the global industry has to do its transformation. Again, I don't know the details, but I'll be happy to meet and talk to you. Next slide, please. So therefore, India has 2 options: concentrate on components like semiconductors, components, interconnections, assembly, and test. That's where India is today with ISM manufacturing. But India could also go simultaneously integrate those and make industry prototypes, prepare itself to produce next generation of products in India, even if India does not make it, even if India does not produce all of them here. And that's because that's the highest value add. So-called chiplet packaging today, so-called 2.5D, they are 10 to 100 times more, okay, in value add than the semiconductors or the components that make up that system. The highest value add is also most appropriate. You don't have to be leading edge semiconductor company until you are. Okay, that may take another 10 years or so. Meanwhile, India could be on a path towards producing the highest value technologies because you already have the design. Next slide, please. So these are the 12 strategic technologies with which almost any country, any company could make any product. Our focus in India, at least the focus that I'm bringing to India, working with faculty and companies, is about AI and computing, 6G, electric cars, and IoT. And so with these technologies, with these 12 technologies, incidentally, each is headed by a professor at one of the universities. For example, top right you see Binod Kumar from IIT Jodhpur. Similarly, others. You can talk, we have Tarun here from Gandhinagar. Tarun, stand up, please. Tarun? I thought I saw him here. Okay, he's from Gandhinagar. He heads up predictive modeling and design. So we've been at this now for 2 years. We have faculty and teams. On the faculty teams, we're now looking for industry leaders in each of those boxes, therefore they can couple with faculty, okay, and so on. I won't go into the details, but when you put them all together by ISRC, that the ministry is going to announce, in my view, shortly, we'll end up integrating all of those to make a highest value add for India. Next slide, please. These are the participating institutions in the country as of now, okay, it's a hub and spoke model. We'll end up creating 12 centers at 12 top IITs and IIC, BITS, Pilani, perhaps others. And then we have a whole bunch of satellite centers feeding into that hub. Okay, so by the time we're through, in my opinion, we end up really connecting almost every part of India, almost every institution in India working with each other. That's my view of what India is capable of. We're getting there, we're not quite there, but we're on our way. Next slide, please. These are the companies, okay? I remember coming here 2 years ago, meeting with the companies like Infineon or TI. Oh, sir, you've been very successful because India had the best design talent, best educational system, is lower cost as well. You've been successful because India has all of that attributes. What if India provides similar attributes in technologies and manufacturing? Would you come to India? At that point, they said, well, all those decisions are made by a parent company. We're not quite there yet. But I must tell you, there are a lot of things that have changed in the last 2 years. Okay, ISM for one, the government for another, okay, on and on and on. At this point, there's not a single company I know of that says it's not interested in working in this research and development program that I'm describing. These are the companies, okay, that are in the process of firming up their interest, getting commitments, be part of these 12 centers, okay? So the new centers at the IIT is very, very different from traditional centers, okay? The typical center in the US, Europe, Japan, Korea, here as well, are about faculty and students. The new centers, I call them, industry co-development centers. They have a lot more than faculty and students. They have research faculty, they have industry engineers on campus, they have pilot lines, state-of-the-art facilities, okay, on and on and on and on. So this is what I learned at Georgia Tech, very successful, and therefore if we can work together, okay, in adopting something like that, okay, I'll almost guarantee you that India could be a global hub. So fortunately, the ministers and the secretaries, they're all in sync with all of that. We're dealing with, the next step of getting the government to announce. I'm basically recommending that the government of India, mostly MIT, fund about 2,000 crores for infrastructure at these 12 centers. And we expect the industry, about 50 to 100 companies, we'll start about 50 companies in the first 2 years. I'd like to see that grow to 100. They will invest about similar magnitude. In my view, about 30% of the total could be invested by the companies. Therefore, for the first time, industry has the skin in the game. Okay, therefore they'll make sure okay, the academics folks do what they need, what the industry needs, and therefore they prepare the technology for manufacturing, making India therefore a global hub, okay, from design to technologies, technology development, manufacturing, and so on. So I'll stop in here. This is the Georgia model. I don't have the time to go into the details. Thank you very much for your kind attention.
Check. Thank you so much, Dr. Tumala. We can take one question from the listeners and attendees over here. If anybody wants to ask any question, if anyone has any question. One question. And Dr. Tumala is here with us for the rest of the day. So if you have any more questions, I think he would be very happy to personally address anyone's question, right, sir? Okay, so one question, yes. Can we get the mic to the gentleman, please?
Looks like we have 3 people raising hands.
Yeah, hello, sir. Sir, what I wanted to understand is with these all universities and programs, what you are telling, these might be very much beneficial for the students who are coming up and studying. I wanted to understand what programs government and with your support we are planning to have with respect to resources which are either in some industries for 10, 12 years and can get benefit from these. Are there any programs, and what we as a professional experiences person need to do to get enrolled in these programs?
Yeah, just to start with, okay, students are integral part of this program. They do research, leading edge research, okay, in all those areas. Okay, let's suppose for now, we end up with about 10 to 20 PhD students, maybe 10 to 20 master's students in year 1. At each of those 12 centers. So that's year 1. Okay, let's suppose to multiply that, okay, by factor of 5 or so in about 5 years. So basically it's all about, okay, so we have a very simple philosophy in US. Best education comes from best research. Not classroom, okay, classroom is fine, okay, we need to supplement that. But really, you want to get students involved at BTech, MTech, PhDs in research, leading edge research. And therefore, they prepare themselves. The moment they join the company, guess what? More than likely, those students, okay, are most knowledgeable about what's coming next, as opposed to the companies that they hire, actually. Okay, so in a way, it's all about creating resources, but expert resources to prepare themselves for what comes next for India and for the rest of the world as well. That's my short answer for now. And here, please. You have time? We have time?
Yes.
Hello, sir.
But how come you didn't give me extra time then? You only give 10 minutes. Yes, sir.
Yeah.
My question is for you, Dr. Sir.
Yeah.
When are you planning to come to India?
When?
Full time.
No, sir. I'm coming for 3 weeks every 3 months.
Coming and talking about.
I am coming 3 weeks every 3 months, okay? As my friends know here, I go to IIT, morning I travel, afternoon faculty meeting, direct meetings, dinner, next morning, next IIT, next city. So this is a routine I established now this for 6th time. So
India needs people like you.
But I'm working from there, sir, 7 days a week. So this is my passion. This is my give back to the country that gave me the very best undergraduate education. I went to Loyola College, then I went to University of Science. Okay, I must tell you, those are the foundations with which I believe, okay, I became who I am to the extent I achieved. So thank you.
Thank you so much, sir. I would request Mr. Vijay Prajapati, Deputy Director, Accounting, GIL. Since you have graced this event and you have given such a wonderful presentation, we have a memento for you. Ek baar zordar taaliyan sir ke liye. Can we give him a big round of applause, please? Also, if you have any questions for Dr. Tumala, you guys can ask him whenever you can see him, attending all the tea breaks and being here. You guys can ask your questions to him, and I'm sure he'll be very happy to answer all of your questions. Now, before I call the next speaker, I would request all the speakers to please see the time that has been given to you for your session. since we have many, many, many amazing industry stalwarts present here to share their insights and knowledge about semiconductors and about the Semiconnect conference. The next speaker who's going to come on stage is going to talk about product design beyond Moore's Law. And we have two speakers here. First of all, I would request Mr. Murthy Dasaka, Vice President, Head of PTK and Design Enablement TEPL, to please come on stage. Can we welcome him with a big round of applause? And we also have Mr. Sankalp Singh, Program Manager, Academic Research and Alliance Synopsis, India, who's going to give the speech and the presentation along with him. Sir, the dais is all yours. Thank you very much.
It's still good morning, everybody. It's not noon yet, so. Can you see me, or am I too short here? Okay. So I would like to actually introduce myself. My name is Murthy Dasaka. I'm a part of this Tata Electronics team, and we are actually creating the entire design enablement and design services ecosystem for the foundry and the other activities as well. I've been with Intel for quite a long time, and I've been working in exactly the same domain where I'm currently going to do it. Okay? Next slide, please.
Thank you very much, Mr. Kim,
All right.
for the comprehensive look into Korea's semiconductor ecosystem. And I request Sir Sanjay Garden to kindly hand over the memento.
There's a side conversation going on. All right, so go to the next slide, please. I'll keep it actually sweet and short. The topic that we are really going to talk about today is about the Moore's Law and its applicability going forward. And I picked up one specific topic and see how the semiconductor ecosystem is actually coming up in India and what our thoughts and viewpoints about it. And my partner from Synopsis, is Sankalp Singh, is going to cover the solution space on this particular topic. Next slide, please. So we all know that Moore's Law has been existing for the last 50 years. Baseline is, you have to double your transistor count for every 2 years and double the investment in the foundry for every 4 years. That law has been on very, very stable stage, both for memory market and as well as for the logic market continuously, because there's a significant amount of design and technology co-optimization, process technology and the design technologies co-optimized such that to keep the law alive. Of late, after 2020, we are seeing as we are going into the lower process nodes, it is no longer scalable at that level. Say, for example, like the law of physics, as Dr. Tumala explained, that you can go only to a certain extent. So how to keep alive? So that's going to one activity. And the ramification is, it's no longer 2 years. Now it is taking close to 4 years to double the transistor count. That's one part. And the investment to pick up the new fabs is quadruple. It's no longer the double. So that's the slowing down tendency that we can see after 2020. Right now, it's going to cost probably around $10 to $14 billion to create a fab of that order. So that is becoming prohibitively expensive. So that's why you can see a lot of consolidation in the fab. There are many fabs are coming together, and some are actually exiting the lower technology game altogether. Okay. Next slide, please. Yeah. So this is what actually. Why do we need to keep the Moore's Law up and running? Okay, industry is trying to find very hard ways to keep the Moore's Law alive, to keep the churning. So there's an exponential growth in high performance computing that's required, as in more and more applications are coming both from software co-optimization, and the data explosion, the clouds, data centers, mobiles, it's actually creating a huge data explosion. So we need more and more powerful machines over here. And large single monolithic SOCs are no longer the thing, because the amount of money that's really required to keep large monolithic SIs are creating a huge burden on the product design teams. So how do we solve it? So there are many research that are actually happening across the board. One is primarily about the multi-core systems, okay? In the product design set, there are two angles. Instead of having a single core, those days are gone since 2010. So we are all more into multi-core. And the next aspect is you don't need to put a large SoCs because the CPUs and GPUs are actually working at a very high speed requirement, whereas your chipsets and the other analog components don't have to scale. So the 3D IC, which is a packaging technology, is a lot more critical going forward. And newer device types are coming, both from the tunnel FETs and the gate-all-around. Nanomaterials are coming, and at the same time, robotic machines. So these are all actually working very hard to keep the Moore's law up and running, okay? So I'm not going to get into the details of it because of the shortage of time, but if somebody would like to have a discussion with me offline, I'll be very open. But there's a lot of innovative ideas are floating around in this one. Next slide, please. So this is actually, next two slides, we're going to talk what we are doing today. So as Professor Rao said, it's very, very difficult to pick up the game with the newer, lower technologies. And India has to actually master the older technology generation because there is still significant amount of market is there. So we have to start from ABC before forming the words and sentences. So this is a very critical for next 5 years to harness the technologies, older generation technologies, and create a good. Where India can add value here is not in terms of the process, but a co-optimization that is required between the design and the manufacturability. So this is where actually India can play a significant role. So if you look at the diagram to the right of this one, so we have an option to do it with a very optimized kits, libraries, memories, and log IP. These are all available in the country today. It's not like that we have to innovate there. And we have a huge EDA global pool systems with strong players. We don't have to do a whole lot of investment. And manufacturing is a green field, which we are developing. A lot of focus is required. So the middle buckets are the product design and foundry. This is where India can add a significant value today because these are the co-optimization that we can add. Even in the older technologies mode, we can bring more manufacturability into the country. Okay. So the reason the white box that I put it there, India has the large number of chip designs and ecosystem players that we can do that. You can see that most of the product companies have their entities over here existing for the last 2 decades. So we do have a large pool of talent, and if we can actually train them very well and use it, we can address many markets over here. Go to the next slide. So this is where actually the ecosystem that in India, we have to focus in the next decade or so. It is not a small game. People have to have a large pockets and they have to have a lot of support across the board. So in the pyramid, it is sitting the foundry. That's actually where we are looking at it. And the chip companies who are actually doing the design and wafer pack equipment, this whole set will get it. But look at that hexagonal diagram that I put together is the yellow ones are the one that we are still at the beginning stage in our journey in India, which is in the fab and OSAT and the entire ecosystem that we have to do. And the green ones, we have a good handle on it because India is providing these kind of services to many companies over the last 2 decades. So we do have a good handle on it. And the middle bucket is the product design. Actually, not many products are happening in India today, so we may have to actually go and create an ecosystem there. And on the system level, yes, we are actually getting good at it because we are borrowing many of the components from outside and creating the system. So we do have a good opportunity to do that. And the bottom pyramid is the government. Unless government comes up and actually initiates certain things through academia, it won't work. That is going to be a very, very crucial picture in this whole scenario. So this, I would like to actually conclude my talk, and I would like to invite my partners, Sankalp, to focus on the solution space of some of these components. Thank you.
Thank you, Murthy. Can we go to the next slide? From Synopsys point of view, as we are into the EDA and the IP space, it is not just the Moore's law what we are focusing on. We have designed a term called as SysMore era, right? And it is not just focusing system on chip, but we are moving away from that to systems off chip, right? So that is where the multi-die and all those things comes into picture, which Murthy just now mentioned. So if you see the life cycle as it is progressing, it is not just the simple chip designing part where we do the DTCO, the co-optimization, we have the PDKs, but the chiplets or the multi-die, the 3D IC, which is the prime focus where we are heading towards, right? Next slide, please. So if we say these are the different verticals of Synopsys EDA stack, right? Be it the system architecture, the design, the verification, the implementation. Now with AI coming into picture, it is the amalgamation of everything. So there is an hyperconvergence which is happening, and at the same time with pervasive AI, we can see that all these things can be intershareable. So whatever we are trying to do in the test space can be shareable with the verification space, and the data is moving back and forth. So this makes chip designing more and more easier. But at the same time, as the complexities are increasing, data will be the thing which will be helping this out. Next slide, please. So I'm just taking two examples to relate with our activity with Tata and for India. So one is on the multi-die system. As we are all moving from simple structures to complex structures, we need to have a multi-die system which will be the need of the hour. And the second one, I'll not go into the detail of that because I've just said it is just 4 minutes. So I'll just try to keep it. And on the manufacturing side, what we are trying to see is work with different foundries, and when we start any process, right, so the defect densities are very high, but the product yield is low. But as the time progresses, there is a lot of data coming in, there is optimization taking place. So there is an inflection point that there is a process analytics giving us that inflection point that from that time onward, the defects will start going down and the product yield will start going up. So this will be something which will be coming very handy to all the fabs which are coming into India. And because we are focusing more on the mature nodes of 28 and beyond, so this is a much more robust system. Last slide. So I'll just conclude that we have been seeing that Moore's law is there for almost 50 years now. And we also see that it is slowing down due to the physics which is getting involved. But can it sustain next 15 to 20 odd years? The answer is a yes and no. Like just Professor Rao has mentioned, there are different physics-based limitations which we are facing. But if I have to summarize this entire thing, we need to move away from just a single thing, a chip, to the system. Second will be the more concept which will come into picture. We will have more chiplets, the multi-die, the 3D ICs coming into it. Newer materials will open up different frontiers. People have already started working on the 2D materials, the graphene and other kind of materials. And yes, we are in the era of AI. So pervasive AI, we cannot neglect. So this will get integrated and we will have new design systems. With this, I'll just say thank you for having me here. Thank you.
Thank you to you both. I would request Mr. Vijay Prajapati, Deputy Director, Accounting, GIL, so please come on stage. And thank you so much for your thoughts and presentation. Sir, please grace them with the memento. Thank you so much. And we are skipping the question and answer part in this session, but I'm sure sir is here the whole day, and you'd be very happy to talk to everybody who wants to have a conversation with you. Thank you. Thank you. Our next speaker for for this session is Ms. Radhika Srinivasan, Program Manager, Academic Research and Alliance Synopsys, India. Dr. Radhika Srinivasan is IBM's Director of Business Development for Semiconductor Research with a history of engineering and management roles at the company. Welcome, ma'am, and the dais is all yours.
Can I control the slides from here, or? Okay. Can you? Okay, so this may be a little repetitious with some of this previous speakers, but we'll just go ahead. And I thought I'd take a little turn and talk about, not quite about design, but more about technology, semiconductor technology, and how it's come through the years. I'll take my 5 minutes to go through it very briefly. Any additional questions, we can talk about it later. So if you can go to the next slide. So computing, or the need for it, is really everywhere. Whether it is today, you have it in the palm of your hand. You use it for small tasks like scheduling, etc. For larger tasks like for the financial industry, and also for more important ones like in the medical industry, where computing assists a lot more the doctors and the medical field as a whole in making it better and more safe and more robust. In fact, just last week, I had both the most exhilarating and the most terrifying experience of hailing a driverless cab in San Francisco and having traveled a fair amount of distance in the traffic in San Francisco. And it was absolutely amazing to see how this can be done today. And all this has been really enabled by the fact that we can make semiconductors, we can scale semiconductors. Can you go to the next slide? We can pack millions and billions of transistors on a semiconductor chip to have it achieve this. So really, what started off perhaps in the past as a few transistors with the capability of doing initial, basic rudimentary calculations, now has become something that allows us to interact with almost every form and every phase of technology everywhere. We also have cloud and edge infrastructure that provides a scalable solution to process tons of data and address applications that demand quick response, low latency, and high bandwidth. So there is also a pervasive connectivity then that with the ability to communicate constantly with everyone and everything. And of course, now in this era, we have AI that is infused in almost every aspect of our life. So all this really requires the ability to pack, again, as I said, millions and billions of transistors into chips. Next slide, please. So normal scaling, traditional scaling meets its limits. So, and this really is essentially the law of physics, laws of physics that govern all this. How do we address it? We have addressed it in the past, next slide, with essentially scaling and making the features smaller. Lithography played a huge part initially in a planar device. Then we decided that we needed more, and that means we went into FinFETs, which gave us more control of the channels and of leakages. Beyond that, the recent technology is with nanosheets, where now you have the gate all around the channel, giving even more control for the channel and for controlling leakage. In addition, of course, materials improvements in the planar with going from high K for the gate materials and low K for back-end operations allowed us to achieve far more than we could have achieved had these innovations not come about. Copper materials as well as processes that have helped us continue to scale have been very useful in absolutely making all of what we have today in the computational field really effective. What is next? Next is, sorry, and now from the nanosheet era, and we really go to the stacked transistor, or the vertical transistor. Can you go back to the last slide? To the vertical transistor, which again offers a whole lot of flexibility which causes complexity of process, but offers flexibility when it comes to the control of device. Now you can go to the next one. Covered some of it, but really, next slide, please. So here again, back-end scaling as well reaches limitations because of resistance and capacitances that reach their limit. They need innovation too, and that's where all of the materials innovations have come in. In addition, next slide. There are innovations that we have to continue if we have to continue to keep the scaling going. Much of that is being focused now on advanced power distribution networks where changing the way the power is delivered versus, Okay, so let me hurry up. Changing by decoupling the power and signal networks with backside power to the wafer is a key area that we have to innovate. In addition, novel back-end devices are also going to have to be explored. Next slide. This has been covered quite a bit, going from monolithic to breaking up the chips and doing chiplet and 3D integration is going to play a key role in our progress in the future. And next slide. And finally, I think you had a whole presentation on this before, EDA, which has been very essential to drive the overall acceleration and adoption of advanced technology, is going to have AI infused in it, scaling, using EDA scaled on the cloud, design and manufacturing co-optimization. All of this will help and aid in the improvement of scaling. And the last slide, really, ultimately, the message here is that in order to accommodate this exponential increase of computing, we really need to continue doing innovations, and whether it is in universities, in research institutions, in industry, this is something that will help to overcome the increasing complexity. Thank you.
Thank you so much, ma'am. I would again request Mr. Vijay Prajapati, Deputy Director, Accounting, GIL, to present you with a memento. Thank you so much. And again, the same tradition we follow, that if you have any questions for ma'am, you can individually ask her later. Thank you so much. Thank you so much, ma'am. And now to address on overall product design opportunities in semiconductor design, I would request our next speaker, Dr. Virappan VV, co-founder and president, TESOLVE, and chairman, IESA, to please come on stage. Dr. V. Virappan, esteemed chairperson of IESA and co-founder of TESOLVE Semiconductor, is a prominent engineer and entrepreneur with a BE form from Annamalai University and an honorary doctorate. Ladies and gentlemen, let's give a big round of applause for Dr. Virappan VV.
Okay, no, I don't have a slide. Thank you. Good morning. 5 minutes time. So I had 12 slides. I have decided to do away with slides. So you will not see a colorful ICs there, nothing. So I will talk like a layman to all of you. That's better than being a technical person. I think Professor Rao and all of them, Ratika has done a good job of explaining to you about this. So I will give us now. I represent a company called Tesol. We are into chip testing. And I also the chairman of India Electronics and Semiconductor Association, which is an 18 years old organization with 350 members. To talk about first I'll talk about a little bit design before product design. You all know that I talked about the Moore's law. To the layman, I'll tell you, a chip is a palm-sized chip. In 1980s, right, the palm-sized chips, whatever IC, it used to have 4,000 transistors, maximum. 4,000. Now we are talking, this will have 4 million plus, the same size. The real estate remained the same, but the number of transistors you have to pack is 4 million plus, it will go on. So in this now, it has to, each transistor is power, right? Power has to go through. So there has to be a distance between both leads, right? There has to be a distance between the board. So I'll tell you a simple thing. You take your hair. I don't have hair, but you can take definitely your hair. So your hair you take, cut into 1,000. Cut your hair into 1,000. That's the distance between two leads in the transistor. Simple for all of you. That's the nano, they're talking nano, right? So your hair cut into 1,000 is a distance between two leads in between a transistor in a chip, in a layman term. So now the technology is coming so much, they talked about all these things. In India, we all started in 1985. 1985, Texas Instruments came to India. To do the EDA, there was those days no Cadence, no Synopsys, I say, Shankar, nobody was there. No EDA tools were existing those days. So each company developed their own EDA tools. So TA came here to develop their own EDA tools. Then only Cadence, all these other guys came, no Siemens, all of them came later. So 1985, some era started in the country. So on design side, now almost like 39 years. You name IDMs or you need a fabless company, we have the design house here. Absolutely, as Mr. Krishnan said, we do 30% of the semiconductor design out of the country in India. Earlier in 90s and 2000s, we never did a tape out of the country. No, we have to do only the block, something they will give you, and the tape outs happens outside. As of today, as per the EDA survey we have done, India is doing 230 tape outs. Means 230 GDS2, means RTL to GDS2 is happening in the country, which is a good number. Apart from this, I think Rao said, no, IITs you can see, we are doing 60 tape outs out of the institutions. So around 300 full tape outs are happening on the semiconductor design side in the country. That is one part. We have about 30% of the design I told you. We have more than 25,000 to 30,000 engineers, design engineers in the country, which is, I can say, around 30% of the worldwide design engineers are in India. That's good news. So design side, we are very, very strong. We are doing about 300 designs. We have a lot of design engineers on the VLSI front. That's one. Now coming to the product design. Okay, it's like, where is India product? Where is India Apple? Where is India Sony? Or where is India Samsung? Now we all of us use, right? All of us use, everybody has got. Where is an India product? But design side, I can tell you, most of the design were very, very strong. We do the design, but we don't have an India product. But product design side, I can tell you, we have more than 220,000 product design, we call embedded engineers we have in the country, which is 10 times of the VLSI design. So we have a good product design engineer, but we do most of the product as service, design as service. See, most of the products, if you do, Wipro has got a big embedded division. They do design the service for other product, not the Indian product. So product design is happening in the country, but not for India. That's the concern we need to address. So we would have, shortly we all have to look at a product which we carry, which is an Indian product, not then a product which is, so we have the capability to do the product design. Unfortunately, we do this product as a service, like what our IT happened, 1990 onwards. IT is also, we did a service. So India has become more towards a service country today rather than a product country. I think in short, if product design has to happen, we have to have India products. India products come in, We'll have more Indian companies go into this. We have a good capability on the product design. For want of time, I've removed all the slides. I'm just telling all of you that product design is a very, very value-added thing in the country. Most of the manufacturing which is happening is more assembly. It's not that product design and product manufacturing is happening out of India. You name your iPhone, you name all this. They're all assembly. Where is the real manufacturing happening? So we as a country have to be very, very clear. We have to relook. Somebody has to come. The big companies have come with the India product. We have to come with India product. We have India design. India designs have mature design. We have all the capability to do product design, but we need product companies to sponsor these India products. With this note, I think I will finish early. Thank you very much. Thanks for the opportunity.
Thank you so much, sir. And to continue the way you started, what a wonderful presentation, sir. We loved your presentation on screen. Did we? Thank you so much, sir. I would request once again Mr. Vijay Prajapati, sir, to please come on stage and felicitate, sir, with a memento. And let's give a big round of applause to all our speakers who have traveled from different parts of countries to be here and be a part of the conference, Semi-Connect Conference 2024. It's time for a panel discussion now. And the very first person that I would like to call on stage is our moderator for the panel discussion, Mr. Sunil G. Acharya, Senior Consultant, Strategic Initiative, SFAL. Sunil Acharya is a Senior Advisor and Consultant to several organizations, including the Semiconductor Fabless Accelerator Lab, Karnataka, Digital Economy Mission, and other companies. Sunil has led leadership roles in strategy planning, driving product management, program management, and business development at leading global semiconductor and technology companies, including Intel, Narus, and he has worked across the globe leading and managing global teams and programs. Welcome, sir. Let's give it up for our moderator, Mr. Sunil G. Acharya. Now I would request all our panelists to please come on stage and join Mr. Sunil. Mr. Naveen Bishnoi, India Country Manager, AVP, Compute, Marvel Tech. Naveen, the India Country Manager and AVP of Central Engineering at Marvel India, manages business operation and represents the company externally. Our next panelist, Dr. Ankit Pal, Director and Head of India Government Affairs and Ecosystem Strategy, NXP. Ankit Pal is the Program Director and Head of India Government Affairs and Ecosystem Strategy at NXP Semiconductors with a rich background in the semiconductor industry. Our next panelist is Mr. Rahul Rao, Distinguished Engineer, IBM. Rahul Rao holds the title of Distinguished Engineer at IBM India Systems Development Labs, where he spearheads the technical directions for a processor design team of approximately 500 members. Wonderful. We have Mr. Sanjay Gupta, Chief Development Officer and Global Head of Engineering, L&T Semiconductor, as our next panelist. Sanjay Gupta is the Chief Development Officer and Global Head of Engineering and L&T Semiconductor Technologies. He has over 28 years of experience in semiconductors and embedded software and system design. And Mr. Arvind Chandrasekhar, Director, Government Affairs and Regional Relations, AMD. Arvind Chandrasekhar is a Senior Director for Government Affairs and Public Policy for Asia, Pacific and Japan region at AMD Inc. and one of the largest leading fabless semiconductor design company. So, sir, aapke naam ab ye pura dais for the panel discussion.
Thank you.
Thank you so much.
So, good morning all, and we've been given a very little time for us to go through this session, but I think very good input from Dr. Rao around what the initiatives that the government should take, and of course we had the technical information from both Synopsys, TEPL, and IBM. So we're going to shift from the laws of physics to the laws of business. So that's the change. So without much ado, I'll quickly go. Our topic has been, what are some of the opportunities in the semiconductor design space? So we all understand that from a business standpoint, the highest market cap are semiconductor design companies today. Manufacturing is very important, but in India, we have a huge strength, like all the previous speakers have said, around semiconductor design. So let's understand from our distinguished panelists, what are some of their views. So I'll first start with Sanjay. Do you want to just give us what you think are the opportunities and what is the market like in terms of semiconductors?
Sure, thank you. So, since time is short, we will directly jump onto the topic. My view is, as was said by earlier speakers, that we are undoubtedly going into a unique opportunity for India. But are we designing products completely end-to-end for the India? And that is where I believe, while great strides in the government and industry to come up with the fab ecosystem, the entire OSAT ecosystem, and among a demand and supply side, I'm sure we are cruising very well in next 2 to 3 years, where India will have a very thriving manufacturing and OSAT ecosystem. You know, thanks to all the 3 to 5 announcements that have happened, and especially in the Gujarat region, which is leading in this. So fast forward, we will have a very robust fabs and OSATs which are going to be ready from the supply side to create chips for India. I think the very important question is where the demand is going to come from. Now, the demand can come in 2 ways. Either the global OEMs, global tier ones, the big ones. If I talk about automotive, for example, the Continental, the Bosch, you know, the Denzos of the world are coming all the way to India to load our fabs and OSATs. The other thing is, what about the Indian ecosystem, where based on the figures, we are in the range of total consumption of electronic, you know, anywhere from $70–80 billion, out of which 100%, almost 100% of semiconductor is imported right now. And the projections are again ranging from $350 to $500 billion in next 3 to 5 years, right? So scenario 1, fabs will be there, but the entire manufacturing demand will be coming from outside India. Or scenario 2, that the Indian electronic ecosystem is rich enough to create the local demand, right? So that is a moot point, and that is where Virappanji was saying earlier, that we are in a service industry, but can we make our own products which are designed in India, which are truly made in India? And I will say that in the last couple of years I got an opportunity to work in a intense Indian ecosystem, in an Indian automotive tier 1. And I felt that, you know, truly in the automotive ecosystem, companies are struggling because of a 100% dependency on outside chip makers. The 70% of the BOM cost is decided by semiconductors. And they really wish that if that 70% was sourced out of India, you know, straight away we will get such a big cost advantage by the local semiconductor players. And that is where right now in my current role, we are trying to solve in L&T Semiconductors, make products for India and for the world. And I believe that that will solve a big problem from the demand side creation. And that is where the entire things can culminate for a very vibrant ecosystem out of India. So I'll pause here in the interest of time.
So thanks, Sanjay. I think the point is that there is going to be a huge requirement for indigenous design, which will translate into products, to Virappan's point of view. So let's just ask our next panelist, Dr. Ankit, what do you see in terms of design opportunities? He mentioned automotive as an example, right? What are some of the opportunities that you see, and what do you think needs to be done to make sure we harness those opportunities?
Thank you so much, Sunil. So I think building on what Sanjay already mentioned, right? So I take my own journey 25 years back, right? So when I was studying in college, on one end of the college, which was having a hostel of 200 meters, there used to be a person calling me, "Oh, Ankit, you have a call from home, and you have to attend it." So I used to run in 2 minutes from one end to the other end in 200-meter race to kind of attend a call from home, right? So we have come to this era in 25 years where the technology has enabled us in such a way that everything is on demand, right? We press a button, we get grocery, we press a button, we get a cab. So this is where all the things from technology has been enabled, especially through semiconductors, where smartphones, laptops, everything has been done. We see the next 25 years from now, so around a 2050 era, right? So that is where things will change from on-demand to a anticipatory world, right? So now you don't need to press a button. In 25 years from now, everything will come to you. The way you will enter a home or a office, lights will switch on, everything will be enabled from that perspective. So that is the era which we are going to enter. And for that, the design has to happen, right? For that, the opportunities has to be created, especially in the area of sensors. So we at NXP kind of cover this in 4 critical ways. We call it sense, think, connect, and act. So it's more of a human form where sensory perception is there, and then we compute our minds, right? And then we connect and network just like we are doing it here. And then we action with our hands, with our legs and everything, right? So what we see is today the connectivity and the action portion is quite strong from technology end, but the sensory end is not, and similarly the think act. So the AI paradigm is definitely making the compute power very much to be there, but somewhere we all as a team and the era which would come, right, we need to focus on the sensors much and more so that this kind of a vision 25 years later can really happen. And what Sanjay was mentioning that India's semiconductor growth, which is currently at $34 billion, would kind of reach to almost $100 billion in next 6 to 7 years, which would be 10% of the global market. But this is just a small one. The product mindset would actually drive this growth, and this would be the key game changer. So at that point, probably I'll take a pause.
Yeah, thanks, Ankit. So again, I think you're reinforcing the fact that there will be a huge amount of demand for design. So there's a huge opportunity for indigenous design, both for domestic products as well as various other sectors internationally, because the use cases are continually increasing. So I'll just switch to Naveen. What do you think, we talked about, Professor Rao talked about creating, industry competency centers which collaborate with the academia to create IP. What do you think we should do on the R&D side and IP creation side to be able to support that requirement which is going to come in the future?
Yeah, thank you. In the interest of time, quickly, if you look at the way I'll connect is that India is seeing the 2 big infrastructure development, right? The physical infrastructure, what we see outside in different cities, and then the digital infrastructure that we see, which all of us are contributing to. And if you look at digital infrastructure, we heard a lot about computing in the morning, and then the computing is going to the scales of thousands and thousands of computing devices and enabled. But what's important is also is that all of this will be interconnected. And then, so connectivity becomes equally important to enable the scale that we are all talking about. And then when we move into this connectivity along with the computing, the storage, and many other elements, comes the need for a lot of R&D, which is beyond just the growth in the computing side, that how much more can I do in a specific operations and all. And then that's where I think a lot of action is also needed from us, that what are the IPs to build to do that connectivity, so that connectivity doesn't become the bottleneck as we go and build this big data centers or interconnected networks. And then what are the IPs needed, what are the R&D platforms for it, and it needs to happen from the ground level, right from the academia, partnered by industry, and then also enabled in a way that it is not just a theory, but is proven on a test chip or on a tape out as well. That's the path we are taking in many such forums. The ISM is very key in that, and then along with that, we'll also need to do is, when we talk about those IPs generation as such, we need to think about that these IPs needs to be conscious about not just the performance, but the power angle as well, right? So that's where a lot of focus is happening and it needs to be built upon.
Yeah, thank you. I think it also connects with what Professor Rao was proposing, that you need to have industry as well as academia collaboration to create IP. So now my next panelist is Arvind from AMD. You are all in the IP space and also in development. So what is your perspective on IP itself? Are there any challenges that you foresee in the IP space?
Absolutely. I think when we start to look at IP as a block, the biggest thing that happens today when you look at any complex microprocessor or any complex design is that the largest portion is all third-party IP. I mean, most people are putting things together today. That's how it is, right? I mean, most complex microprocessor designs would have less than about 20% of own IP and 80% of licensed IP, right? You're borrowing stuff from, you're taking it from others. Hence, actually, IP banks become pretty important. The government, for example, has already in a way, I call it democratized EDA tools, right? I mean, there's an EDA cloud available where startups can go in and do it. Now, the reason for doing something like this is that these blocks essentially cost a lot of money. And hence, when we come down to the capital side of things, is that you're talking about $300, $400 million plus in a single design cycle, which needs to be bridged. No Indian startup has that kind of money to go after something as big as this. And hence, I think having a similar IP bank will help put it together. The second part is that of the entire IP that exists today that is usable and commercially deployable, I don't think any of it is in India. It belongs to multinationals largely from outside of India, which could be in the US or China, etc. And hence, managing this would have to be done through partnerships, which means that if India needs to start building IP and you start today, it will take us 20 to 30 years to, kind of get to where we are. And then by then, the entire ecosystem has leapfrogged. So there has to be a significant partnership model that has to be arrived at. Multinationals today face a lot of issues in such IP-related things, largely which are associated to tax laws. And the second part is beyond the tax laws is actually associated with taxation itself, is about how you don't want to get taxed on a global turnover. That's a major challenge. So how do you bring it to India? So I think these are some of the key aspects that revolve around IP. And the way I see that an Indian product design, as Veerappan had mentioned very specifically, that we have to evolve something in India. And in order to make an India product design, it has to be the crawl, walk, run approach. And the crawl approach has to be done by MNCs such as ourselves. And in fact, if you look at this panel, every single person apart from L&T is a multinational. So it's the onus is on us, is completely on us, right? As the multinationals in India, leveraging from India, developing talent from India to give back to the community we are taking from, which means that the partnership model is where it has to evolve from.
Yeah, thanks, Arvind. Just so that there's a couple of points that were brought up around IP being generated in India and Veerappan's point around having products. I have to plug in my thing also because I'm part of the Semiconductor Fabless Accelerator Lab. And pretty proud to say we have more than 43 companies who are developing not just IP, but also end products. And the fund problem, the governments have supported, but also they have got invested from VCs and PEs. So we are seeing that movement as an opportunity. There is a capability for us to develop indigenous IP, which translates into a finished product. And I think Sanjay is aware of some of those products also. So the capability exists. The question would be how to take it to the next level. But I think the taxation angle is perhaps input to the government folks here. It's a much larger discussion for them to have, especially around managing IP as we go forward. Now that I've already got the 00s behind me, so in terms of timeout, so I'll just go through a quick round of any other thoughts that you may have in terms of challenges or inputs after we finish with Rahul. I just wanted to time you. Please go ahead.
I'm under the gun here, right?
Yes.
So, a couple of things which I want to highlight is, and I think very well articulated, that even today our curriculum system is built to design hardware like a software. We are pretty much a software nation, and that's what we do with hardware as well. And if you want to change that, I think that's something, a paradigm we need to change. The best experience, seeing is believing, but doing is eye-opening. We have a lot of designers in the country. How many of them have actually held a chip? How many of them have actually tested it? How many of them have actually manufactured it? So from a curriculum modification point of view, I think that's something we should think about. Can we build a holistic course where people go through step 1, design, step 2, manufacture, step 3, test, over a multi-year or multi-course semester process? Right? So that's for the educational folks out here, how we should change. And I'm a faculty at IIT Madras, so I take the blame partially to myself as well. From the corporate point of view, we typically say that the talent that's coming out is not industry ready. And I think that's something we need to alter. We've got to make sure that the curriculum is suitable for what we want to do in domains that we want to do. So it should not really just be a skill development exercise. It has to be a domain development exercise tying into the products that we want to build. And so my call out to all the industry folks here, we can be adjunct faculties. We can be the folks who go and get those students who are graduating out to be more industry ready. And that's something we have to do, in my opinion, to accelerate the journey that we want to. So with that.
Thanks. Go ahead, Ankit.
Yeah. So I'll just add on to some of the opportunities further which are there from the ecosystem and especially the government. So big thanks and gratitude to government for having extensive schemes. But I think it was a mention in the morning session also, the scheme on design link incentive. So that is something which people should take benefit. More and more startups should come and experiment. We have an excellent startup ecosystem inside the country. So Sunil Acharya is coming from SAFAL, Semiconductor Fabless Accelerator Lab, which is in Bangalore, Karnataka area. But then you have Electropreneur Park, which is in Delhi and Bhubaneswar. So again, from system solution design, it's an excellent place to kind of be. IIT Hyderabad also has Fab CI incubator, which is again an excellent facility which is there from semiconductor design incubation perspective. A lot of our multinationals, I think 3 of them are having a free scale background here. So we have ex-NXP vice president, ex-NXP design manager as well. So a free scale heavy. But a lot of these corporates have programs which are running for startups, for mentoring, for mentioning that they kind of cultivate collaboration and innovation together. So that is something which again can be very beneficial along with the academic ecosystem which Rahul mentioned across. Thank you.
So I want to take an opportunity to mention we are very keenly, as the only exception, not a multinational, but an Indian company which will be multinational from a semiconductor standpoint. We are very keenly looking into the innovations that can happen in India ecosystem as well as a global ecosystem as L&T Semiconductors. And I'm very happy to say that within last 6 months since we got birth as this Indian company, you know, innovation is not the only thing that can build the biggest GPU in my mind. When we look into some of our customers, whether it is the automotive domain or industrial domain, you know, we find that one of the biggest things they're looking at is a board which has more than 150 active and passive components, out of which probably 50 are the chips. And they say, for us, the biggest innovation is, can you convert them into a single chip? And I think that could be the biggest thing for value creation, because that will directly impact their BOM cost. You know, as an end customer, if something they are building in a, let's say, 20,000 rupees, if you can convert that into 10,000 rupees, by just merging chips, that could be the biggest innovation for Indian entrepreneurs and IP creators. And I think that is what we are trying to attack to begin with. And we see it's such a low-hanging fruit. And inherently for the global companies, there is a self-cannibalization effect, you know, that we saw. That if they try to do that, they will kill their own chips. And that's why the OEMs or Tier 1s are surprised why global companies are not doing that. And that is what we are attacking. And I see immense value. So it is an invitation to all of you who want to pursue. There's a great opportunity that are lying.
I was just kind of building on Sanjay, just to kind of mention the focus angle, right? So it's more of a statement from Bhagavad Gita chapter 2 verse 41. There's a word which mentions buddhir ekaha, right? So it's a time when if we can focus on the product in India, it will happen, and it will happen for sure. Yeah.
So I'll use this very quickly, since so much of design bit was brought up. Is that, let me just illustrate illustrate this through an example in complex processor design. Is that if you were to look at the mobile phone market in India, you're talking about 200 million, 170 million, depending on who you want to believe. It's anywhere between 170 to 200 million. Huge amount of semiconductor usage inside it. If you look at the processors that go inside that, it's dominated by maybe 3 or 4 players at best, right, globally. India is the world's 2nd largest smartphone market, right? So you have so India has a huge leverage, power, play, etc., which is there. So you also have a consumption market. And if you look at the processor complexity that's built, that's about 70 to 80% is essentially licensing. It's only 20% is integral, right? Most of, whether you're using an ARM processor or a Mali GPU, whatever, right? I mean, it's all licensing. And for example, if somebody like an L&T were to make something on that order, which is an India processor, and you're talking about, let's say, capturing 10% of the market, it's between 70 to 20 million odd dies that are going to come out, processed dies, apart from the surrogate thing which is there. And technically a fab viability comes out at about 16 to 18 million odd dies, right? Which is about, you're talking about 15,000 to 30,000, about 30,000 wafer starts per month. So you kind of have a viable business model emerging slowly. And if somebody puts in the 300 to 500 million initially that is required to build something like this, and you're talking about, let's say, a $50 ASP coming out of approximately about 20 million odd process, you're talking about $1 billion company at a 54% gross margin on day one. So the money, so it just pays itself back in no time.
Yeah, so I think the point is that it makes business sense to actually have design or design-led manufacturing in the country. And like I said, the discussion is moved from laws of physics to laws of business. That was the whole idea. Naveen, any closing comments?
The only one point that I would add, we are talking about products which is built on the IP. One important part of that is all the standards that needs to evolve so that we can interoperate, we can connect all of them and ensure that they can work through the integration, faster integration, and then get the product out. So standards, some of the open sources will be a key part of that design ecosystem.
So Rahul, anything, or I can wrap up?
I think it's covered.
So thank you, everybody. I think the key message is that, design is good business, firstly, and that we have the capability in the country. We do create products, just for Veerappan's sake. We do make products. It is not that we only do services, and we have those products. I know. So you make small, okay. And to Dr. Rao's point, I think everything that they said reinforced your point that you need the, industry co-development centers to basically, make sure that whatever is coming out is productizable. So I think that made a lot of sense. So thank you, everybody, and thanks for finishing up so quickly.
Thank you so much, but it's not the time for you guys to go off the stage.
Somebody has a
Please
question.
be on
We
stage.
can answer it, I think, off the stage, if that's okay.
Can we get the mic there, please? We have one question. Please quickly, आप वहाँ पे mic भिजवा दीजिए.
So when do you start your design cycle?
Hello, myself is Pinakin Thakur. Thank you very much for this interesting panel discussion. And really, I have just one question is, we are talking about Indian product and the collaboration between academia and industries. I am founder of the Saptarshi Academy in Ahmedabad, which we are having a finishing school and developing the students. So my question is one, that we are developing the IP. So we need to help you people that list of the IPs, which down the line 5 years, what industry is going to use. I think that will be the big help to the finishing school. So people can have a direction on which I think they can focusly work on that. Already we have developed few of the IPs, and finally we are going for the silicon proven thing also for software defined radio. And I work, this is why I was started is my experience of in this field more than 38 years in Space Application Center, ISRO. And it is giving back to the students. So there is, I just need to have a collaboration of academia and industry. Same time, finishing school can also provide the good industrial experts. So directly, when they go from the finishing school, I think they can work directly to the industry. So what I think government is doing, but what industry is also going to initiate anything for this?
I'll answer it really quickly. Is if you can go to the Ministry of Electronics, METI website. Professor Tumala Rao last year was a part of what's called as the India Future Skills Talent Committee report that's been published. That has every detail that you've asked for available. If you just go through it, it's all there in it.
Okay.
And if I may add, which IP you said one of the things. Again, I have last 6 months, very simple example. Every mobile phone has a RF chip. Every communication that we are doing in the base station has RF chip. Every single RF chip is imported right now in the country. So in your finishing school, if you focus on RF, I think this is the 90%, 80% gross margin business, and you can have your IPs.
So that's from 4 to 6 gigahertz band?
Anywhere from a low end to the high end, the whole RF space is wide open for Indian companies to start, and it is something that is directly starting even close to curriculum, close to the circuit design and analog world. That could be a very good starting point. We can talk offline on so many other opportunities.
Thank you.
Thank you so much. Now I would request Mr. Vijay Prajapati, Deputy Director, Accounting GIL, to felicitate all our panelists. What a wonderful session it was, and I'm sure everybody enjoyed listening to you all. So first we'll start with Mr. Naveen Bishnoe. India Country Manager, AVP, Compute Marvel Tekken. Dr. Ankit Pal, Director and Head of India Government Affairs and Ecosystem Strategy, NXP. Mr. Rahul Rao, Distinguished Engineer, IBM. Mr. Sanjay Gupta, Chief Development Officer and Global Head of Engineering, L&T Semiconductor. And Mr. Arvind Chandrasekharan, Director, Government Affairs. And last but not the least, our moderator, Mr. Sunil G. Acharya, Senior Consultant, Strategic Initiative, SFAL. Let's give a big round of applause to all our panelists and moderators. And this was the end of first session. Please stay back. We have another interesting session coming up. Mr. Arvind, yes. Thank you so much. Thank you. Thank you. Since all the panelists and moderator is on the stage, I would request all the speakers to also join us for a group picture along with the session coordinator and the team. Let's have a quick picture here. And after that, we are going to start our next session. For the 2B session, all the panelists and speakers, if you're present here, I would request you guys to please come in the front. I would request all the panelists and speakers of our next session, that is 2B, to please come in the front. Thank you very much. Thank you so much. Thank you very much. Yes, we are going to take up the next session now. Thank you very much. So the next session is about transforming Gujarat into electronic manufacturing services hub. Gujarat has the potential to become a major hub for electronics manufacturing services, that is EMS, and this session will outline the steps required to achieve this transformation, focusing on infrastructure, policy, and investment. And to take over this session, I would like to call on stage our very first speaker, who's going to address on advanced substrates in semiconductor packaging. Let me call on stage Mr. John Park. John Park, with a BS in Business Administration from Seoul National University and MBA from Santa Clara University, joined Simtech, focusing on a new business development in Seoul. And in 2011, he transitioned to Simtech America in San Jose, CA, where he spent a decade as a technical sales director in the system IC semiconductor market. So let's welcome Mr. John Park with a big round of applause, ladies and gentlemen. Also, I would request everybody to please settle down. I would request everyone to settle down. We have our first speaker of the next session on stage.
Okay.
I would request everybody to please settle down so that we can start our next session. We have Mr. John Park as our next speaker. Please settle down.
It's okay, yeah. I can wait.
You can wait?
Yeah.
Thank you very much for that.
Yeah. Well, session just, finished.
Yes,
so,
of course. The
everybody
session
need
is-
a, bathroom break, I guess.
But before that, I would like to ask you, since we have few minutes in hand, is this the first time you're coming to India or you're attending such conferences?
No, actually, this is my second time.
Second time.
Coming to Gujarat.
Coming to
Actually,
Gujarat.
Yeah. So I actually attended Vibrant Gujarat back in January.
Wonderful.
Yeah. So there was a huge event, right? So.
Great.
Yeah, it's great to be back here.
We also love that you're back here.
Thank you.
So I think we are all settled now and we can start the session. I would request all our dignitaries who are standing on the side, all our guests and attendees to please settle down. We have our next speaker, Mr. John Park, with us, already on the dais to share his thoughts and presentation on this conference.
Okay. All right. Let me get started.
Yes, thank you so much.
Namaste. Hello, everyone. Yeah. Yeah. Good. So I'm John Park from Simtech. We're PCB and substrate manufacturer based in Korea, and we've been expanding our presence globally to support our customer locally. First of all, it's a great honor to be here and to share with all of you here how Simtech we evolve ourselves to support our semiconductor customer globally. So today let me share Simtech's strategy on how to support our customer base through fine-tuning our technical capability and also locating ourselves locally together with our customer. So a bit of myself, I'm leading Simtech International Business based in Singapore, where our international headquarters is located. As briefly mentioned earlier, Simtech is a PCB and package substrate manufacturer based in Korea, but we do have a manufacturing site not just in Korea, but in China, Japan, and Malaysia. So I'll briefly cover a little bit more details later in the slide. And so we, as a PCB and substrate manufacturer, we are a major PCB and substrate supplier for top 5 major memory IC customers and system IC customers. Also, from here, we're also having #1 market share in the world for memory module PCB and packaging for ETS substrate and NAND packaging as well. So let me share a little bit of more details about Simtech first, since you may not know about our company. So we were founded back in 1987 in Korea, headquartered in Cheongju, which is actually located in central part of the Korean peninsula. And ever since, and also we were listed in Korean stock market back in 2000. So it's been about more than 25 years now already. And ever since, we've been expanding ourselves globally and opening our 6 regional sales offices and 4 manufacturing sites in globally. And we have about 6,000 employees globally as well. And our revenue reached up to $1.34 billion USD back in 2022. With that, with the product that we manufacture from our 4 different manufacturing sites, PCB and substrate, we support electrical interconnection for most of the electronic devices, including mobile, server, PC, and wearables, and automotive. So this is our showing our locations in globally. So as I mentioned you earlier, we have about 6 sales regional offices, including Korea, US, China, Japan, Taiwan, and Singapore, and 4 different manufacturing sites, including Korea, China, Japan, and Malaysia. And each site here has a unique capability to support various and dynamic customers' requirements from each site. Just to giving you a background of where we are in the supply chain. So these are just briefly showing our semiconductor supply chain overview. So as you see, we're sitting in the middle, and we're working together with IDMs, so-called integrated device manufacturers, like you may know Samsung, SK Hynix, and Micron. All those memory customers are under this IDM category, and we are directly working with them. At the same time, OSAT, Outsourced Assembly and Test House, are our direct customer as well. And not just that, we're also working together with design houses like families companies like Qualcomm, Intel, and Apple, because they are the ones who design packaging substrate and packaging the component for semiconductor chips. So families customers, families design houses are the ones who design the chip, and wafer foundries like TSMC are the ones who fabricate the wafer, and we fabricate the substrate. So we ship it out to OSAT, and OSAT is the one putting together from wafer and substrate together as a component. And similar logic going into the OEM and subcon side. So we ship our PCB, the manufactured PCB, to our IDM customer or sometimes subcon, contract manufacturer, and they're getting this component from OSAT and making into the module. So making as a memory module or SSD module together. That was a little bit of background of our supply chain in semiconductor industry. And moving on to our memory product lineups that we support for the customers. So here's a product lineup that we support our memory customer, IDM customers. So the PCB that we manufacture from our factory, it goes into memory side as a memory module PCB and SSD module PCB, which becomes memory module and SSD later on. And for the substrate that we manufacture, we do also support various type of product, starting from PC server DRAM for conventional PC, laptop, desktop, and raw NAND is mostly for SSD packaging, and for graphic DRAM is for graphic card, and LPDDR, eMCP, and eMCP for mobile and automotive devices. So for all this product type, we manufacture from 4 different manufacturing sites in Xi'an, in Penang, and Chino, and Korea. And these are the system IC product lineup. So in semiconductor, memory and system IC, same thing under semiconductor umbrella, but little bit of different feature. So for the system IC, we do mostly support with our substrate product. So starting from memory-based product like RCD and DB for server RDIMM, and SSD controller for SSD, and AP, application processor, and RF, Wi-Fi module, and SIP mostly for mobile devices. And for automotive and consumer SoC, the structure is similar, but we do also support those industry with the substrate that we manufacture. And let me dive a little more details into the memory IC packaging trend here. So if you look at from the left side, DRAM, so conventional DRAM, DDR, is for PC and server, and low power DDR is mostly for automotive and mobile devices. And for graphic DDR is for graphic card, and it also goes into the mobile devices and automotive. And this one requires MSEP process from our substrate manufacturing point of view. So if you look at the down from the table, there's a 2 different process called subtractive, tenting process, and MSEP, additive process. So which is the way that we are making this patterning for the interconnection on our substrate. And going to the HBM and wide I/O DRAM, those 2 are the new memory type. I guess you may hear a lot about this HBM recently in the news and media, called high bandwidth memory for the very high performance and high speed memory product, which is mostly applied into the server for AI application. And for NAND side, customer is still utilizing conventional package structure, so it is mostly going into the SSD and mobile for the storage requirement in the market. So let me see how this then memory packaging market is growing. If you look at from the right bar chart, from 2023 to 2028, this memory packaging market grow from 16.5 billion market to 31.8 billion US dollar market. Within about like 5 to 6 years time span, the market is growing about like doubling the number, so which is very fast and dynamic market, big growth, as because of the AI demand creation, not just AI, but all the consumer devices and all the connectivity, it requires a lot of memory into the devices. So this memory demand is keep growing. That's why our memory customers are expanding their front-end and back-end facility. Same thing goes for us. We are trying to keep up with the pace with our customer to increase our capability and capacity. So because of this dynamic market situation, we, Simtech, believe that it is so important to keep up with our customer more than ever. So that is the reason why we, Simtech, try to keep up with our major customers like Micron when we globalize ourselves, each and every location. If you look at the map, most of our regional sales offices, actually, we were following Micron's footsteps. Wherever Micron required us to be there, we go there, we support locally. And two remarkable, milestone for us was actually we started this business relationship with Micron back in 2000, and starting from 2011, we followed their factory and built our factory next to them. In China, that's the first project that we did, and in Malaysia, the recent one was the second project we developed together with Micron in Penang. And for India, it's an upcoming one. We believe that this co-location strategy could be applied to the India as well. So just showing our historical, background with this co-location strategy. The first one was in China, Xi'an, back in 2011. So Micron opened their facility back in 2008, and after 3 years, we opened our factory there in Xi'an, in China, and we support their PCB requirements. So in the beginning, Micron started building their memory module in Xi'an. So we started supporting memory module PCB from Xi'an, and now they build not just memory module, but moving on to SSD and other package type. And we also cater our capability to support Micron's requirement in Xi'an. Again, we apply the same strategy in Penang, Malaysia. So Micron opened their facility back in 2019. Again, we followed them after about 3 years. We opened our factory in 2022. And again, we support their requirement, whatever they need from us to support locally, from PCB to substrate. So these are the projects that we support for Micron in Penang. So then India. We are also, working together with Micron and Indian government to consider how to, evolve ourselves, how to position ourselves locally in India. So obviously, our venturing into Gujarat, India, is one of the co-location strategy, just like what we did in the past. And at the same time, we are also closely working with Gujarat government and central government for the opportunity that we can co-work with them as well. And obviously, this will position us, Simtech, to penetrate into this Indian local market where we haven't been able to engage in. Now it will be the chance for us to get into the market and work with a local customer here in India. Of course, there will be some homework to be done. Making this as a what we need will be the skilled workforce engineer and infrastructure to be equipped to support semiconductor component packaging. There are a few hurdles to overcome, but we do believe that we can work out together and transform Gujarat into electronic manufacturing service hub. Thank you.
If anyone would like to ask any question, we are open to take one question. If anybody from our attendees.
Yeah, please.
For substrates. So given your experience for manufacturing substrate in China and Malaysia, do you think India could be the lowest cost producer compared to those two sites for these type of products, for memory products? Memory, as you know, I know just as much, memory is extremely cost sensitive. So you want the lowest cost country to produce.
That's right.
So my question to you is, could India be the lowest cost producer compared to any other countries that you're currently manufacturing?
Yeah. Well, thanks for the question. I think, that should be the answer that I need to hear from you guys, right? So when we first moved to China, obviously, everyone was jumping into China because of the cost, right? They have a, number of labor force, and, they actually enable a lot of manufacturing facility to enjoy the cost benefit there. But again, now what's happening in China. Cost is rising up, and everyone's is, like competing each other. It is not easy to compete against local Chinese supplier there. So a lot of them are moving to Southeast Asian region now. Malaysia is one country, but a lot of them moving to Indonesia and Vietnam. And as a Korean manufacturer, we see a lot of other Korean manufacturers are moving into Southeast Asia as well. But again, question to you is that whether India is ready to fight against and compete against this Southeast Asian workforce and the cost benefit there. That will be the question they will have. Infrastructure and building a factory is one thing, but obviously, as you said, memory is so cost-sensitive product, so we really need to work together. We coming to India, and a lot of Indian workforce, all the infra and industry has to work together to compete against all the suppliers and all the component maker in the world. So I guess that's something. Let's leave it as our homework, and let's work together, becoming a competitive and be successful together. Thank you.
Thank you so much, Mr. Park. Now I would request Sri J.B. Vadar, sir, session coordinator of this session, also Executive Director, Gujarat Science City, to felicitate you. Thank you for the presentation. Let's give a big round of applause to Mr. Park. Thank you. Our next speaker, who's going to talk about creating semiconductor manufacturing hub in Gujarat, is Mr. Satish Kumar Ambardar, Head Technical and Fab Build TEPL. Please do not mind, it's written panelist over here. Sir was a panelist in the session at 1A, and he's our speaker, keynote speaker for this session. Welcome, sir. Mr. Satish Ambardar has a 31-year tenure at Semiconductor Laboratory, where he was a group director and outstanding scientist leading the establishment of water fabrication, MEMS fab, and assembly and test facilities. Sir, the dais is all yours. Let's give it up for Mr. Satish Ambardar.
Okay. But I think it is not that visible, so I have to see the slides now. So, okay. I can continue. Yeah. Namaskar, government dignitaries, friends from industry, and ladies and gentlemen. Good afternoon to everyone. So I'm very grateful to be a part of this distinguished forum. Thankful to the government of Gujarat and the Gujarat State Electronics Mission for providing me this opportunity to share a plan and vision on creating semiconductor manufacturing hub in Gujarat. Next slide. Next. Yeah. Next slide. So this gives a flavor of the Indian semiconductor market. Okay, the semiconductor market, as you can see, is growing very rapidly. From $27 billion in 2021, the projection is that it will go up to $110 billion by 2030. So this growth is propelled basically by the growth in the automobile sector, in higher consumption, consumer electronics, as also in the tech-driven areas. So, yeah, currently almost 100% of the semiconductor consumed in the country is imported. So this is a significant opportunity for the semiconductor companies in India to tap this potential. Next. Next. So here I would like to say that following the Tata legacy, we are going to make a significant mark in the semiconductor and electronics value chain, positioning as the global supplier of as a global supplier. So offering end-to-end services from design services, foundry, that is a wafer fabrication, semiconductor assembly and test, and we are already into EMS in a major way in India. Next. So here this slide shows that we are building up a 300 mm fab in Dhulera. So this is going to be the India's first commercial fab, and we are partnered with PSMC Taiwan. It is going to be a 12-inch, that is 300 mm wafer fab, and we will have multiple nodes, and from 110 nanometer to 28 nanometers, and catering to the automobile markets, and basically it will be a high-performance computing logic chips and into the memories and also into display drivers. So these are the market that is currently under focus. As you can see that the Dhulera, as you can see in the picture, that is the top picture is the site where this facility will come up. Next. So we feel that we strongly believe that Dhulera is best positioned to serve the Indian semiconductor market and be the hub of the semiconductor manufacturing. So there are various factors, like it is located strategically nearer to the port, nearer to the seaport, nearer to the airports. It has got the infrastructure that the government of Gujarat has created is quite appreciating in terms of availability of power, water, and road infrastructure, and a lot of reliable power, and green power would also be available. So the key differentiator is in Dhulera is the government's commitment to build an infrastructure and provide all the necessary support to the industry. So Tata is committed to develop this as a semiconductor hub in the country. Next. So to make this as a semiconductor hub and to create that ecosystem, so the best example would be the Hsinchu Science Park in Taiwan. You can see that it started all in 1974, and today there are more than 400 plus high-tech companies in Hsinchu Science Park. There are TSMC, there are UMC, PSMC is there. You can see that the numbers that are on the right-hand side, how this industry, semiconductor industry is making a big mark on the economy of the nation. So this is a good example for benchmark and then emulating what steps they took in creating that ecosystem and facilitating the setting up of the fabs there. Next slide. So as you can see, TSMC started, in 1987, and then in 30 years, they developed a very strong ecosystem in Taiwan. So the three key pillars are, the government support, training and research, and the industry ecosystem. So with right support, so Tata is committed to build a foundry ecosystem at Dholera in next 8 to 10 years. That is the commitment from Tata. So basically the message that is being conveyed is that with policy support and infrastructure research and development, these are the key parameters for transforming into a global hub. Next. See, this slide depicts the intricate supply, the supply chain system that is needed for a semiconductor foundry. You can see right from construction, the utilities, then the equipment maintenance support, logistics, then the equipment itself, direct raw materials, and then indirect raw materials, chemicals, photoresist. So it is complex and right now heavily dependent on imports. So there is a significant opportunity for the suppliers, overseas suppliers, to come and set up their, establishments in India and serve the semiconductor. It is a win-win situation for both the foundry as well as for the potential suppliers. Next. So as I mentioned, the benefits, it is beneficial for both the foundry and for the suppliers. It can, the first benefit that we see is that with being co-located in the semiconductor fab, near the semiconductor fab, it provides a very clear visibility to the suppliers on the needs of the foundry so that they can align align the requirements accordingly. Like, the other one is the logistic cost and damage. If it is co-located nearby, it lowers the logistic costs and damage-free delivery. But at the same time, the global suppliers, they can diversify their presence by setting up their, establishments at Dholera, nearby the Tata fab. And then it also results in accelerated R&D. So the suppliers will have a first mover advantage. Whosoever comes first, they will have a considerable amount of advantage. And also they will have access to the industry-ready talent and common infrastructure that would be made available as they come here. Next. So here are some of the actions that are suggested for localization opportunity for semiconductor suppliers. So the first one I would like to talk about is so mostly the equipment right now in the near term, they will have to be imported unless we start developing them. But there's an opportunity that the silicon wafer ingot facility for manufacturers of the silicon wafers itself, it's a good opportunity that for the potential industry to set up this in Gujarat on a long-term basis. And also these equipment, there are consumables, critical consumables like quartz tubes, rings, O-rings, which can be immediately manufactured within the country. Then coming to the chemicals and gases, as you know, for a fab of 300 mm, and which is operating in technology nodes of 28 or 45 nanometer, about 45 types of gases are used, and most of which are specialty gases, and they are quite hazardous in nature. And about 60 types of chemicals, photoresists, and the slurries that go into the manufacture of the ICs. So about 100 types of chemicals and gases are used in the process. So right now, it's all, most of it is imported, except for the bulk gases, like, the nitrogen, oxygen, or hydrogen, argon. Rest of all the specialty gases. So this is a major opportunity for localization, for diversifying their presence. They can come here and set up there's a ecosystem park that has been made available by the government of Gujarat in the activation at Dholera, which will be quite co-located with the very near to the Tata Fab. So this is another important and key opportunity is the photomasks. Photomasks are extensively used in the fab. And to start with, photomask repair and preventive maintenance facilities can be set up. And then as a next step, then photomask manufacturing can also be established at Dholera. The third opportunity is the warehouse services, and because most of these chemicals and gases need to be stored and kept in a very environmentally controlled conditions. Shelf life is very limited, and they have to be kept under a controlled temperature and humidity. So this is another opportunity that is available for the potential investors. Next. So logistics is a critical factor, because once, so we have to have logistics which can support the transportation of these semi-grade purity level handling, and the equipment handling is very important, because these are very sensitive equipments, and any tilt or shock would be externally damage these semiconductor tools or the equipments. So so damage means a lot of expensive. It costs a lot. So each part would cost about millions of dollars. So that's why logistics, creating a good logistics network is very important. And this will not only serve the fabs, it could serve also the other factories, the EMS and the other ecosystem partners who are willing to locate in Dholera. So as I mentioned about warehouse, this is required for any semiconductor fab as part of the ecosystem. And also importantly, lastly, the utilities. Right now, the process critical systems like the ultra pure water plants, like the chemicals and gas distribution systems, they're all imported, heavily imported. There are no manufacturers available. Because when we talk about the ultra purity water plant, it means this water comes into contact with the wafer at least 20% on 20% of the processes, which means and about 3,000 to 4,000 liters of ultra high pure water is needed for processing one wafer. So which means this water is very critical, because it comes in contact with the wafer. So this is a technology that we are making. We have deionized plants manufactured in India, but their technology capability is not to the level that is required for the semiconductor plants. So this is one area where the local the industry can collaborate or develop their own technologies to generate ultra high purity water plant. The second major opportunity is in the chemicals and gas distribution system and clean rooms. So as I mentioned, a number of gases and chemicals are needed to be transported from the source to the tool. So this is a very, very critical and very important from the perspective of contamination as well as from the perspective of safety. So right now, this all is also imported. So this can be a potential area of future investments, and as we grow more, as more fabs come in India, so this will be a good business for the companies, not only to serve the local industry, but also to become a global partner. Okay, so next. In summary, I would like to say that the Indian semiconductor market presents a golden opportunity the market is going to up to about 110 billion by 2030. And global semiconductor companies have already taken a long-term view, and they are quite interested in partnering with the Indian companies. We have made good progress in terms of infrastructure, in terms of the government policies, but still a lot needs to be done. So, and the vision, finally the vision, our Tata's vision is to create a global semiconductor ecosystem at Dholera. It is committed to do that, and with the close collaboration between the government and all the stakeholders, including the academic institutes, the industry players. So there is a strategic imperative of developing this supplier ecosystem within the country to serve the needs of the emerging semiconductor fabs in India. So with this, I conclude. If there are any questions.
Thank you so much, sir. So we do have one question. So please, आप mic पहुंचा दीजिए वहाँ तक.
Okay.
Thanks for the presentation. It's quite eye-opening. Could you make some comment regarding the criticality of different, like you mentioned, solder mask, photoresist, but anything regarding the metallization, chemicals, how critical it is to obtain it in Dholera and overall supply chain logistics?
Yeah, as I mentioned that chemicals and gases, they are the key enablers for, making the semiconductors. Without chemicals, they change the electrical conductivity of the wafers. So the most important thing is its availability, and availability at the same time the purity levels, because we are talking purity levels of 99.999%, 9 nines, and sometimes some of them gases are 8 nines, 9 nines. So that is a purity level. So right now it is totally import driven. So having these suppliers, these manufacturers in the ecosystem at Dholera, it will create, it will give the advantage in terms of availability. We don't have to create stocks. Because right now all these are being shipped by sea. Yeah. So a lot of time is getting wasted in the sea shipments. So by the time the chemicals and gases reach here, their shelf lifetime is very limited. So there are wastages in that sense. Yeah. So it is very imperative that all these gases and chemicals are very near to the site of manufacturing. Of course, so there is, although chemicals are being made, but then we need to have these manufacturers collaborate with overseas companies for refinement technology, because refining these chemicals to that, removing metallic impurities and all that. So that is a technology that needs to be developed within the country or collaborate with the overseas companies.
Thank you.
So we can take one more question. Please, mic पहुंचा दीजिए वहाँ तक. Thank you.
Hello, sir.
Yeah.
As a localization, you mentioned the silicon
wafers
manufacturing.
Yeah.
But the need of the hour is in India, the gallium arsenide and gallium nitride and 3-5 semiconductor wafers. That is the need of the hour. Silicon, definitely you have included, but my question is there any scope for Tatas to develop the manufacturing capability of 12-inch dia gallium arsenide? That is the need of the hour, because it is all RF, as we have been talking since morning. So, there is a great need. See, as of now, we are importing all these gallium arsenide wafers. Even today, we are importing. So just I am asking the question, if you just focus on silicon, what about gallium arsenide, 3-5 semiconductors? Yeah. This is the question, sir, kindly.
See, first of all, gallium arsenide or 3-5 semiconductors, they are not into 12-inch right now. They are into 6-inch or 8-inch maximum. Okay, that is first thing. And then, see, we have ventured into this semiconductor. Tata has ventured into semiconductor. So right now the focus is on the CMOS. But as we go along and we are successful in running this and, creating the market niche in the India as well as catering to the requirements of the global. So there is nothing like, stopping us from venturing into 3-5 semiconductors also.
Okay.
But right now the focus is on the CMOS, okay? Because it's a very complex industry. Setting up and running this industry is very complex. So as we progress and we make good stride in CMOS, we can, think about venturing into 3-5 also. But it is not that CMOS has a significant, it will continue to be the major market.
Yeah, I agree, sir. I agree. I agree with
But you are right. 3-5 semiconductors or gallium arsenide or gallium nitride, these are also emerging markets. There are companies who are setting up the facilities, not in India, but overseas. But we must focus on that. That is also a good suggestion.
Okay.
But right now we are into this. And as we progress, we may think about venturing into that.
Thank you so much, sir. Now I would request Shri J.B. Vadar, sir, to please come on stage, Executive Director, Gujarat Science City, to felicitate sir for such a wonderful presentation. And if you have any questions to ask, sir is present here the whole day, and he would be really happy to address all your concerns and answer all your questions throughout the day. Thank you so much, sir, for this wonderful presentation. Our next speaker is going to address on navigating the future of EMS through innovation. I would like to call on stage Mr. Debashish Chaudhary, VP and Country Manager, Jabil. Debashish Chaudhary is the VP and Country Manager for Jabil's Inc.'s India operation. With over 25 years of experience post IIT and IIM, he previously led Sanmina's India business as VP and played a key role in the Sanmina Reliance JV. Ladies and gentlemen, let's welcome Mr. Debashish Chaudhary with a big round of applause.
Good afternoon, ladies and gentlemen. Is it audible? Is it audible? Oh, yeah. Thanks. As I told, I am the Vice President and Country Manager of Jabil. Jabil, we are one of the largest EMS of the world, or largest American EMS with $35 billion revenue. Our Indian revenue is $1.5 billion, which is 14,800 crore. Not sarcastically, one statement I want to pass here. In electronic manufacturing in India, we Jabil don't assemble anything, not a single rupee. All 14,800 crore we manufacture. My colleague, Mr. B.N. Shukla, who runs the plant sitting here, any of esteemed member can contact him. He will like to host and show you. And there was a second question, compared to Malaysia, will the electronic manufacturing in India will be cheaper? Answer is unambiguous, unequivocally yes. A taxi rate in Bangalore or in Delhi per 10 kilometer is 1/4 what you pay in Kuala Lumpur in Malaysia. You bring an apple-to-apple comparison of the cost, it is there, it is benchmarked. So I'm not going into that. This is out of the turn comment. So I had not having a presentation. I will not take more than 10 minutes. I would like to close at 9 minutes, 59 seconds. My research team had given me to tell about what is this innovation in electronics is going to be there. So first, why electronic manufacturing service is needed, and before that, a cryptic message. Jabil is evaluating to set up one of the world's biggest EMS plant in Tolera. So that's on our discussion line. So today, giving a quick example, why we EMS people need to live in the world and important, the two most prominent products, electronic technology products of the world, Apple and Tesla, 100% they are made with the EMS. 80% of the Fortune 500 electronic products are manufactured by EMS. So EMS is going to define the next level of the technology, growth, etc., all this there. So now the question is, what is the EMS innovation is there, and why I'm standing here to tell that the most required next generation or to the survivability of the EMS is going to be here, and we are driving on that. So typically the traditional EMS is build to print, we call it. Means get it the design, DFM, it is we manufacture and we give it. Typically the electronic manufacturing had moved, the history tells us a lot. moved from the Second World War in 1950, etc., from Manchester, which was in our UK and European Unions and Americas, to 80s, 90s to the Tokyo, from 19 onward to the Shanghai, and Guangdong become the main major hub with the Shenzhen model till 2010 and etc. And then there came Shenzhen, Hong Kong, Taipei, based of the EMS services, which maintain the supply chain visibility, NPI, prototype building, vertical integration, forward integration, all those lexicons or the paradigms of the EMS, which was that till 2020. In 2020, all these are going to be disrupted. The next movement in the next 20 years, by 2030, India is going to be the next EMS hub, or another second Shenzhen or Shanghai is in the making. Is perhaps we are standing in the location which is in the Dholera, around on the Sanand, etc. This is not far away, might be 4 and 5 years away. So why I am so overconfident? Supply chain is the crux of the story. I am going to share here a very public domain system. During the COVID time, close to watch 1 billion population, only one more country is having, they also delivered the COVID vaccine. It's publicly available. India spent 22,000 crore, not the medicine, on the delivery of the COVID vaccines. 22,000 crore, it's spoken in the budget, means $2.2 billion. The other country which has $1 billion population, they spent $10 billion. It's publicly available, public domain, you can validate. US spent $7 billion. So I'm not going into the detail, what USP in supply chain, service, logistics, cost, value addition there, and there was not a single failure. The people, even to the remotest in the village of Arunachal Pradesh, to that of the Kerala, to the Kashmir, were administered, they were called for the second dose, a certificate was given. All these had happened in public domain. So the criticality of the supply chain and delivery system, all these things. So those are in bed. There is, then what is the innovative point is coming? This is the second point. The manufacturing or the electronic manufacturing is perhaps coming or emerging to cloud-based manufacturing. Those traditional, I will give you a design, you do, you give me the supply chain, you store it. No, nothing. In India, it will be like a private cloud, like the way the clouds, those are happening. So here we are going to have, or the EMS is going to be an extreme confluence of softwares, hardwares, and design engineers plus professional service. So there is the only place in the world which has the lowest cost, domestic consumption, growing economy, plus all these has been established here. So that's year is coming into the India. So this is the place where the innovation going to disrupt totally from our backyard. So what is then the addressable market? Everything is going to be, this is going to be the $5 trillion addressable market. Again, it's verifiable. The 4 key emerging segments of this EMS industry, as we are talking, is one we call CEC segment, cloud enterprise communication, which is the telecom products. Second is this AI autonomous, AI's automations and robotics. Third is the EV and green energy. Fourth is the healthcare. If we add up all these 4 things, which is growing and which is primarily dependent on EMS industries. In Jabil, recently we acquired an semiconductor arm of Intel, photonic semiconductor. So the main reason we found it out, as the AI robotics is going to grow, the data centers are going to grow. Anyway, I'm not going into the technology. So for these 4 key growing segments, if you put, there are some 12, 16, or 18 major segments what the EMS is targeting. These 4 key segments gives an addressable market of $5 trillion. So from $5 trillion, in a futuristic view of a net 10 to 15 years, India is going to consume at least $500 billion. So from $500 billion, if 30% is going to be consumed or manufactured in India, the very conservative addressable EMS opportunity business is $150 billion. And Dr. Ambardar was saying about the processor need. So all these are going to be integrated. Perhaps So the innovation which is going to come here is, repeatedly here, I want to throw a paradigm here, or we are seeing the synergies. 70% of the Fortune 500 companies who started after the supply chain or disruption of this COVID as a China plus one, now they are not talking India as a China plus one. They are just talking India. Yes, India manufacturing. Cost is definitely there, and there are now lots of manufacturing happening. And the third main thing, the main key paradigm of the disruption is, we are the proud designing and service company. Today, manufacturing, if it moves from that legacy manufacturing, the next generation, next disruptive manufacturing, which is beyond the ODM model or beyond the JDM model or beyond the DMS model. So that innovation is going to be from India. And we see in India this location of the Gujarats, this Ahmedabad cluster, Dholera, Sanand, etc. This is going to be the center hub. So this is a very short thing. I spent it out. So I'm done. I think I exactly closed on time. Thank you.
Thank you so much, sir, for that. If you have any question, I think we can take up one question. Anybody, if you want to ask anything. So yours was a very clear session, I guess, clear speech, I guess. Let's give it up for sir. And I would again request Shri J.B. Badar sir to please come on the stage and felicitate sir. Thank you so much. Now we are moving towards the panel discussion, and I would call the moderator for this session on stage now, Mr. Vinod Subramaniam, Vice President, Technology Cluster, ESDM, ITBPM, and Telecom Invest India. Welcome, sir. Mr. Vinod Subramaniam, leading the technology and telecom sector at Invest India, boasts 30 years of industry experience with tech giants like Oracle, Salesforce, and HCL Infosystems. As the founding CEO of Logo Infosoft and former head of the IT advisory team for TMT sectors at EY, he's an expert in strategic and business advisory with a deep understanding of accounting, supply chain, and customer relationship management processes. Sir, I would request you to please come on stage and join me. Our moderator for this panel discussion. Now I would request all the panelists to come on stage one by one. The first panelist for this session is Mr. Josh Folger, President Zetwork. Josh is an experienced electronics industry leader with a 30-year career in manufacturing, supply chains, and robotics, having worked with top firms like Nokia and Foxconn globally. Our next panelist is Mr. Raghu Panikkar, CEO, Case Semicon. Raghu is an electronics and communication engineer with over 33 years of diverse experience across industries, cultures, roles, and international locations. Next panelist for this session is Mr. Satendra Singh, CEO, Sirma SGS. Satendra is the CEO of Sirma SGS, a design-led manufacturing company in India with 12 plants domestically and 1 in Germany. A seasoned global executive, he has over 30 years of experience in strategy, operations, supply chain, manufacturing, and business management with international corporations. Our next panelist is Dr. Ravi Bhatkal, MD, McDermid Alpha. Dr. Ravi Bhatkal manages McDermid Alpha Electronic Solutions India, a subsidiary of the $2.3 billion Element Solutions Inc., focusing on semiconductor sector in India and Southeast Asia. These are all our panelists. Thank you so much. And sir, the session is all yours. Please take your seats. Thank you so much.
Thank you. Hello. Good afternoon, everyone, and thank you very much for joining in. We've had quite a bit of interesting talks right now, starting from Simtex, PCB substrate, and then, of course, my friend Debashish from Jabal coming and talking about EMS. Allow me to set the stage with 2-3 opening comments, and then we'll walk through 2 rounds of questions with the panelists, talking through the trends in the EMS industry, and also the opportunities and threats. To set the stage, overall EMS as an industry globally is about $1 trillion. India is, I mean, you look at different stats, it's between 2 and 3% is where India is at this point of time, approximately about $30 billion. Globally, this industry started taking shape almost parallelly in 1997 with a whole bunch of players, which you are very familiar with the names, Jabil, Flex, Foxconn, Sanmina, etc. coming up. And then, of course, the next set of players, Pegatron, Winstron, all came up in the 2005 to 2010 timeframe. India had a bunch of players. Actually, this is a power-packed panel that we have here. Eminent leaders from the experienced in the EMS space. India, we had Sirma starting off in 2004, and it was set the stage and moved forward. We had Keynes coming in 2008, Zetwork, which is not really in the EMS electronic space, but a hardcore expert in the manufacturing space, started in 2018. The players have actually crossed, 600 crores, 1,000 crores as revenues, and they are at the stage where they can, really leapfrog into the big league. We also have McDermott Pharma, which is a supplier for circuitry, semiconductor assembly, as well as film and smart surface solutions, supplying through the whole chain of electronics, also represented here. Interestingly, McDermott has been in India for 93 years now. So there's a whole lot of history here, expertise. The EMS industry fundamentally is you can look at it in two parts. There is a very heavy B2C part, which is what you typically look at as mobiles, consumer electronics, and to an extent lighting. These are high volume, comparatively lower margin products. And on the other side, you have automotive, IoT, industrial, all of which comparatively are lower volumes, higher margins. And usually when the industry starts, they start from this side because that's where the margins are, and then over a period of time, they move into the high volume space. And we have representation from both sides on the panel. So with that, I'd like to ask the fundamental opening questions to all of them. There's a lot of changes happening globally. What are the trends that you're seeing in this space? Josh?
Thank you, Vinod, and good afternoon. We are standing between you and lunch, so we'll try to be quick. I just wanted to say on a personal note, I was here in 2010, and I first had the pleasure of introducing ESDM to Mr. Modi, at the time. So it's really, really great to see, and what Debashish is talking about, you following the semicon industry into Dholera, Sanand, in this neighborhood, I think it's pretty laudable. So very, very happy to see all of that coming together. In terms of trends, I think, the overall ESDM industry today is $3 trillion. It's going to go to about $5 trillion in the next 5 years. Companies like us are starting to take advantage of this. I think there are a lot of technology trends, which I necessarily don't want to talk. I think there's enough technology today. But the geopolitics are really pushing things here. And one of the previous speakers talked about India. I think what is happening is India manufacturing, India electronics manufacturing or EMS manufacturing today is about 100 billion, which is going to go to about 500 billion by end of the decade. So a lot of growth opportunities just on scaling up in India. And I think that's the trend which I think we need to catch up. I also see the known clusters of electronics manufacturing shifting from, let's say, the NCR, Chennai, Bangalore, Pune, to things beyond. And I think we are here in Gujarat, and hopefully we do this. We in Zetwork today, we make, somebody mentioned that India is a software country. I hate to disagree. I think we are also a manufacturing country. Zetwork today makes about 1 device a second. There are a lot of people here who do similar things. When I was in Nokia back in Sri Perumbudur, we used to make 7 devices a second. So India is also a manufacturing country. So I think the trends are really looking positive and in favor of India. So,
thanks, Josh. Josh actually has a long career history with Nokia and Bharat FIH, and he has actually put India on the global map on this front. So thanks for your comments on this space. Raghu?
So I tend to agree with what Josh mentioned, that when we ever say that we started the software revolution, it just started when Infosys started, right? I go back to my times. I'm talking of 1983s and stuff. People who have lived that life would always know companies like Western, companies like Oneida, companies like all those television manufacturers. And we were the world beaters at that point in time, right? I'm not going beyond that what happened, but then we were a manufacturing house at that point in time. So Josh, point well taken. Now, coming to say, what are the trends that are happening? The trends are many, and people have talked technology, people are talking of AI, which is a much buzzword now. We, at least in our organization, are planning to put a few systems in place. Now, those systems could be, let's look at how the data is coming, machine-to-machine communication. What do we do, study of the data, how do we optimize that, and how there can be a process improvement that is to be done, which is very simple. But that's the heart. We've been always trying to put certain other systems in place. I have my friends here in the audience, Siemens guys here. So, we have used them. They've put a beautiful system, which is called Design for Manufacturing, which is again a word which we have been always talking about, but I think it is to be worth implemented. When we say design for manufacturing, looking at what are those manufacturing techniques, what are those challenges which you face during manufacturing, putting in the design phase itself. Or if you get a Gerber, how do you run a DFM, make sure that it is ready for manufacturing? These are two systems which we felt that would be talked about. Then other trends, and if you look at companies outside of India, be it Malaysia, be it Taiwan or Thailand and Philippines, there are these 40-year-old and 50-year-old, which are not the tier 1 and tier 2, maybe tier 3. They all started as an EMS company. And then slowly branched into doing semiconductor assembly and test and packaging and stuff like that. To one such effect, I think we are also treading that path to look at what are the two components which are mostly imported into India. And primarily to our EMS is nothing but the semiconductor and the bare board PCB. And if we can effect that to different kinds of plants, I'm sure it's a job well done, and then also help to bring the import duty down.
Very well said. Thanks, Raghu. He's an expert in EDA space, and good luck to you on the Semicon venture. Can I have you?
All right. Good afternoon, everyone. First of all, let me start with thanking Government of Gujarat and the people who are involved in organizing this event. Morning, I was talking to some of my friends, I wouldn't name them, and I was saying like this is very, very well done. So everything, the logistics, the way event has been done so far, the experience has been flawless. So thank you organizers and every one of you who is behind the stage and has worked many weeks to put this event together. Now coming to electronics manufacturing, I would touch on two topics actually. First is there is a discussion around cost, and going to the point Debashish made. I really loved what he said when he said the answer, will we be cost competitive, is absolutely unequivocally yes. I agree with him. I've been a proponent of this thinking that it is absolutely possible to make cost efficient and cost effective products in India. Now, there's another element to it. The other element to it, there is something happening around the world. And that something which is happening is around automation. It's not a new word, every one of us knows it. But there's a lot more happening, and usage of AI, machine learning and automation, that combination, that's being used very effectively around the world. I joined this company about a year ago. Before that, I was in a global role at Nokia. I also have the same legacy as Josh. We were this morning talking, we were almost like 8 years together in different parts of Nokia. So in my previous role, I was looking at the global manufacturing ecosystem. There is a significant improvement in the productivity, in the cost levels which anybody can achieve. And particularly when we talked about India, we always said that we have an advantage of low-cost labor, if I use that word. That advantage is disappearing. It has not disappeared, but it is disappearing. So that's a little bit of challenging news for us, and that's what we need to as Indian manufacturers be aware of. Because with the combination of AI, machine learning, and automation, I will use automation in the global context, the productivity can easily leapfrog anywhere between 30 to 40%. So that narrows down the cost gap. So as much as I'm saying to you, this is a challenging news, I'm not using the word bad news, because there's a good part of it as well. The good part of it is, end of the day, what is it all about? AI, machine learning, and automation is all about engineering skills. And I don't have to tell you what kind of engineers, how good engineers we have in India, and so many talented engineers we have. And that's one of the secrets of the manufacturing operations I have been a part of. I've been fortunate to be a part of a couple of them. Everywhere, what we have done, we have always beaten the global best benchmarks in the cost. And how we have done is using that engineering skill. So the point I'm trying to make is, despite the fact that we still have low cost labor, we have cost of engineers or cost of the shop floor people is still lower, let's not forget the fact that we need to focus on these three things: AI, machine learning, and automation. Now I'll change the word automation to low-cost automation. So in India, what we need to do is we need to be mindful of the fact that the business case of investment would be very different. And that means the kind of automation you want to do has to be low-cost automation, not plain super sophisticated automation. Pick up what's relevant for you, customize for yourself, and work on it. So that's the point which I wanted to talk. And the second topic, from my perspective, is that we need to use the opportunity which the rest of the world has presented to us, which is the diversification of supply chain. And the nuance there is, India is not becoming an automatic choice. It's not that, when somebody is looking to diversify from our other Asian neighbor, then India becomes automatic choice. That's not the case. So we need to be aware that the supply chain is moving three ways. India is in the equation. There is another country in Asia which is in the equation, and then people are going closer to the market, which is the US and Europe. So the supply chain movements, when they are happening, they're not happening one way, they're happening three way. So our competition as Indian industry, which I'm representing today, is with another Asian neighbor, in this case Vietnam, with countries which are closer to the point of consumption, which is Mexico, and certain low-cost countries relatively in Europe. So with this, I would turn it over to Ravi.
Thanks, Satyendra. Very well said and very inspiring from the India perspective. While the global EMS industry is growing in that 4 to 6%, given the reasonings that Satyendra talked about, India is growing at upwards of 30%, doubling every year. So very well said. And the AI and automation piece, absolutely powerful, because everything is measured, tracked, and you have a whole lot of data points available. Of course, the ability to optimize becomes much, much better, and low-cost optimization is what you talked about. Ravi?
Thank you. First of all, thanks to the Gujarat government to have put together a fantastic conference, and amazingly, as Satyendra mentioned, amazingly well organized and incredibly well done. So thank you. Just a quick note about our company. We are a multinational, we're a US-based public company, about $2.3 billion globally, focused in advanced materials. The biggest chunk of our business is in electronics. We go from chip to box, as I like to say, from back end of line semiconductor, making damascene copper to connect the transistors, to taking the signals and power out to the package. And we make packaging materials for the package. We make materials for PCB, fab. We make materials for board assembly. We make materials for final assembly. So actually we go from sort of chip to box. I think you see the chart behind me. I'll get to that in a second. In India, we've been here for about 93 years now as a manufacturing multinational. So we started manufacturing in India in 1931 with smelting, and we evolved over time. We've been involved in electronics since the early days. In fact, I was mentioning to Radhika Srinivasan that we partnered with IBM to convert the industry to copper from aluminum on chip in 1997, 98 timeframe. So that was 26, 27 years ago. So it's long history. We've sort of helped build the electronics manufacturing industry in India. We have very good infrastructure in India: Chennai, Pune, Bangalore, Delhi, etc. So in terms of trends, I would say if you look at the chart, a few, other than the geopolitics, etc., that is already being covered, I would say from a market standpoint and technology standpoint, I see and I have seen this for the last 10 to 12 years or more, that the energy value chain and the electronics value chain are converging, or have been converging for a while. In fact, today you cannot talk about electronics without talking about power consumption and efficiency of power consumption. You can think about the entire chain as either the flow of information or the flow of energy going both ways. And this is important to understand, because when you consider the markets and the products and the technologies, you need to consider both simultaneously. Below that, you have the telecom infrastructure, and below that, you have what I would call the value chain, manufacturing value chain from level 0, which is the semiconductor or the silicon wafer and other wafers, level to fab, to package, to substrate, board assembly, and final assembly. There are, I would say, a few core technologies, and that includes electrical, electronic, thermal, optical, protective, and energy conversion. And what I see as the imperative, and it's beginning to happen, is the localization of these technology platforms. When you really look at what does need to be localized in order to move the needle in a big way. One is, of course, the manufacturing infrastructure and the scaling of the manufacturing infrastructure, which is really proceeding extremely well. The second layer is the underlying technology platforms that actually power this manufacturing infrastructure and the advanced technology that is behind it. So as we move forward, I would suggest and say that this is one of the key aspects of moving the entire ecosystem and value chain forward here. The third part I see is, and I know Professor Rao Tumala gave a talk earlier today, is the build-up of a research ecosystem and people development within advanced universities as well as research institutes, etc. I see that as a growing trend locally, and I would say that it's going to be an absolute imperative going forward. It's just a quick synopsis, and we can take further questions.
Thanks, Ravi. I mean, when we think of semicon, we always think electronics everywhere. There's a whole bunch of chemistry and energy and power-related things behind, and thanks for bringing all that up. Probably I'll start the next round of questions with you. Given these trends that we are seeing, what do you believe are the opportunities and threats for India as a country and for Gujarat as well, if you want to allude to? Probably I'll start with you, Ravi. Factor conditions, do you want to start with that and talk through some of the opportunities and threats?
Yeah, I think, I mean, shorter term, I would say the factors of production that we are already competitive, as Josh, Satinder, and Debashish have already talked about. But I think for the next level, we have to do it in a coordinated way to take it systematically and lower the cost of energy, lower the cost of infrastructure, lower the cost of capital. Because remember, when you factor in the cost of capital is a big aspect of it. So all of those things, right? Input costs going in need to be lowered. And the second aspect, of course, is the technology platforms that are going in. across the ecosystem. So the more you localize, the better off it's going to be. Going upstream and not, I think we started final assembly, we went into board assembly, we're going into PCB fab, we're going into packaging, we're going into semiconductor. Time to look at the three-dimensional aspects of everything else that's being fed into those nodes across the value chain, be it equipment, be it materials, all of those aspects of it. I mean, we live in an interconnected supply chain. We cannot be isolated from, it's a global environment. As I think Sagar mentioned in the other session, a chip crosses borders 70 times before it goes into its final product. That's the world we live in. So, but to have the critical infrastructure in place is important. And so this needs to be looked at in a holistic, on a holistic basis. So if you want ecosystem development holistically, people, materials, components, equipment, and then the activities being design, modeling and simulation, manufacturing process, and then testing and reliability. So those aspects, I think, need to be systematically developed over time.
Thanks, Ravi. Very, very well said. And yes, I mean, this industry is definitely a value chain. There's a global value chain. We're thinking of building the India value chain. Satinder, would you like to pick up from there and talk about the resiliency that's required in the, the value chain and the, for us to be successful as we move on to become a strong player in the EMS space?
Thanks for the question. I think resilience is an interesting topic. This was never discussed. It was always known. So for those of us in supply chain and many of us here in the supply chain, it was always known. We always knew that it is important. We always talked about it as important. It never got the attention all the way up to the CEO level in whichever company it was. There have been isolated instances. Every now and then something happens in the world. And people say, yeah, let's do something about it, and they forget it. Whether it's Suez Canal or there are different events at different times. Some factory getting impacted somewhere. But I think there was a big shift in the thinking around 2015-16, wherein the bipolarization of supply chain, as I call it, started to happen. Many of the supply chain professionals were caught off guard, if I would use that word, because the supply chain was very concentrated in essentially in one of the Asian countries and very, very heavily dependent on that country. Unfortunately, COVID happened, and that accelerated the need to ensure this resilience becomes the topic of the board discussion. So every company is talking about supply chain, is talking about supply chain resiliency. Now, supply chain resilience is not something which happens by talking about it or saying that let's have tomorrow morning we will have a resilient supply chain. You have to really drive it. The word is drive. And why I use that word, and I said it again because this is my acronym for resilience formula. So first, on drive, we're talking about diversified supply base. So as a manufacturer, when I talk in our context, EMS, we need to have diversification wherever possible. By that, what I mean? By that, I mean using multiple suppliers, using supply from multiple locations. Locations could mean different thing to different people. It could for some mean different cities. It could mean different states, or it could even mean different countries. So to your context, make sure your supply chain, inbound supply chain is diversified. Equally important, your own capability is diversified. Like in our case, we have 18 factories spread around the country. We have factories in North, we have factories in West, we have factories in South, and we also have a footprint in Europe. So diversify wherever you can, your own footprint as well. Second, R. R is for relationships. Build wherever you can. Again, pointing towards the supply base as well as your ecosystem partners. It's not necessarily suppliers. It's anybody else in the ecosystem, which is material supplier, service supplier, which is your customer, government, and whoever else. Third, do it intelligently. Now, what does intelligence mean in our context? It's not the usual intelligence which we normally talk about. It's about using the data from your supply chain, from your manufacturing floor, use it, process it, make sure you're thinking through and making the decisions accordingly. So that means I'm going back to what I said in the previous question, which is use of data, process it, use the AI wherever you can, use the machine learning, which is, there are umpteen examples wherein machine learning and AI are being used in the manufacturing floors today. The intelligence doesn't come unless you have the visibility, so that's the V part of it. That means you should have the data being captured from the floor. So in our case, we use the MES, we use the systems on the supply chain side, we use the systems on sales side, we use the systems on the finance and the quotation side. So everywhere we have the digitized systems wherein the data is coming in and we are processing it and it's visible. So if I need to see something, I have it available. So make sure the information is visible to the people who need to have it. It does not mean that everybody has access to everything. So depending on the need, make sure it is visible. And the last thing is, don't rest on laurels. You have done everything. Keep enhancing the E, enhancing the capability. And here I mean the first thing is the skill set. Make sure the people are learning multiple skills. So when you need to use them into different products, different factories, doing different things, they are able to do it and enhance everything else. So diversified, relationship-oriented, intelligence in the data systems, visibility of the process and the information, and continuously enhancing it. So drive is the word to drive the resilience.
Excellent. Thank you very much, and new learning for all of us. By the way, when we look at multinational, they build a whole business on models which are resilient. So a lot of things that you talked about, diversifying the supplier side, ensuring that you are available in any location irrespective of what happens so that you can deliver for your customer. Very, very powerful indeed. Raghu, would you like to tell us about, again, the opportunities and threats? You could pick up maybe a couple of topics. You want to pick up AI automation, you can, or if you want to pick up OSAT and how that links to the EMS, whichever of your choice, Raghu.
Yeah, so thank you, sir. Sometimes, life is very cruel. You look at the software world, or you look at the electronic design automation world. The guys who write software, and you look at their profit margin, it is as high as 80%. I don't want to name the EDA company. One of the EDA companies last year booked a profit of 80%. And here we are sitting and talking 10%, 12% and stuff, right? So having said that, now, I entirely agree with you what you said. Supply chain resilience, faster turnaround time, quality process standard, localization, and all of that. But let's look at what we are doing in our EMS part of the world. What we are doing is, since we are an electronic manufacturing services company, which by any means is not a bad, services is not a bad word because, we've learned a lot from servicing. What we are doing is, look at the two components. I'm again taken from that point of view of doing OSAT, doing semiconductor package. And what we did is that, we did a study about what kind of packages that we are in-house consuming in our EMS. And we saw that those packages are mostly towards the wire bond kind of packages. And those are packages which are, high volume in nature. And we saw there is a good percentage of close to 18 to 90% of those packages which are using in-house. Second, we looked at, what will this affect? Let's take an example now. We are big suppliers of automotive products, the lighting solution, and power management solution. So if we do some of these packages in-house, these packages could be used in those modules which eventually people are doing EMS and supply to the OEM. So net-net, I'm going to bring the price down for the OEM. Third, if I bring in a bare board PCB in the entire ecosystem, I again bring the prices down. So I guess these are some of the things that our friends are also starting to do. So you have seen some of the EMS guys are also looking at OSAT as a basis to reduce cost and stuff.
Excellent, and wish you good luck on that journey. We have covered a whole bunch of topics on the value chain, how do you optimize within. There's one topic that we haven't really touched, which is about talent and workforce. I mean, having run a really big people-centric operations in the past and the learnings from there, Josh, can you tell us what is the opportunities and threats for us there?
No, I think when I came back to India 20 years ago, there was the biggest fear I had was, can we do this? Do we have the talent? And so this was when we bought Nokia mobile phones to India, and I can tell you the experience was just delightful. We chose a formula of 90% women and 10% men, and we won't go into those reasons, why, but and it was just a remarkable success. The technicians we picked, 80% were freshers. We trained them, we skilled them. 20% were very experienced guys. We stole from Raghu and some of the other companies, and when we started, and it was, within a year, Nokia factory became from the newest baby to the best factory in the whole world. We had 9 factories around the world, including Korea and China, and we beat all the factories there. So next year what happened was we went on our India Plus journey. We started to export to SIAP, we started to export outside. So talent, in my mind, I think India is probably one of the very few countries which actually offers a full spectrum of talent. ESDM is something which demands a full spectrum of talent, staff, a range of staff, right from design engineers, to supply chain, professionals. The technician supervisory force is very, very important. These are the people who manage things 24/7 in our shop floors. And then, of course, comes the full bulk associates. And in my 2 previous companies, we were 90%, and in my previous employer, we were 100% women in our ops. And we have had remarkable success in actually implementing that in scale. I mean, these were 30,000, 70,000, people operations operating in India. So clearly, India has achieved scale, as well here. So whatever is the sort of threats and opportunities, I see India going from India demand to India Plus, so that we're going to bridge that 100 billion to 3 trillion. And I think our full spectrum of talent, will come into play as we go there.
Excellent. Thank you very much for that very positive comment. Lots of words of wisdom from the panel here. I'm going to finish up with my last rapid fire question round. I was actually wondering if we have any of the Gujarat team members here. I'll come to the audience after this. So the question is, hey, while we are so confident about EMS as an industry and the potential that India has and the talent that we have and the ability to compete globally, there's nothing in Gujarat at this point of time. So if there is one wish or ask that you have to Gujarat to bring EMS industry in India, we've got clusters in other parts of the country at this point of time, what would that be?
I should not be beaten. Let me say this out anyway. Get Pari Pasu here. Or more laughs. No? Why not? Yeah. So, okay, no, what I meant to say is that, get closer to customers. As we all have grown, we have seen that getting closer to customer always helps. I've heard that, guys Jabil is coming to Dhalera, so that's one good thing. Hopefully, with all the capacity that we are building in semiconductor manufacturing in Sanand, there could be some EMS lines, because that would help to build the ODM business or a module business beyond that. So hopefully that's the good thing to do. Taking a leaf off on the capacity building, which is a very interesting topic, and we also believe that, so look at the design world. These guys went to tier 2 cities to bring the cost down, because, cost of engineers are very less compared to Bangalore, Hyderabad and stuff. But still, with that cost of Bangalore, Hyderabad, these guys are booking 80% profit. So, we are in the tier 2 cities like Mysore and other cities. But hopefully going to such places would bring the cost down and be cost effective.
Thanks, Raghu.
One point on, actually 2 things on Gujarat. See, one I think is Gujarat is located very close to what I call as an adjacent nearshore market, which is Middle East and Africa. Big bulky products, TVs and other things. If you're looking at an export, Gujarat stands to benefit. So I think I would explore opportunities, to look at that. All of these products, large format ESDM products like TVs can be made by EMS companies in Gujarat, and they could be exported to a similar size market, Middle East. Of course, there's 69 countries, but it's a nearshore opportunity. You can just ship them out and then really start to compete with China or Asian tigers, right? So I think that's one comment. The second comment I will say is that, see, we have seen 10 years of very consistent policy from the government at the center. Extremely consistent policy, Make in India, Atmanirbhar Bharat, and now the Prime Minister has set us on the Viksit Bharat journey. Companies like us, people like me, we have jumped on that bandwagon and driving it. And I really see Gujarat already on track in aligning, with the central's policy. So I think, I feel that Gujarat is already aligned, maybe not on the EMS side. So maybe we can further discuss. Debashish has already thrown the gauntlet, so maybe we also, some of the Indian companies like us also have to respond, to that, and we'll see what happens.
Absolutely. Love the Atmanirbhar pitch there. Satinder, what's your ask?
So I was thinking about what should I say on this while 2 of you were talking. So I say 3 things. First, I think you are well on track. You are doing all the right things. So far, whatever you have done, very well done. Now, when I close my eyes and say, what will happen 10 years hence? Because some of us said that we were a manufacturing nation, and then there was a debate that we were not manufacturing nation for a decade or 2 probably, and now we are getting back to manufacturing. So there's one word which comes to my head, which is stickiness. We need to make sure the business model is sticky, which means if there is an EMS, they have reasons to ramp up and stay, which basically means you need to be competitive. Now, how does that, what element of competitiveness I want to talk about is, we need to make sure that there is a closer link between design and manufacturing. So that link has to be established. There are a lot of successful design companies. There are a lot of successful manufacturing, and as the state need to focus on. And second thing is on the supply chain. I think there's a lot of discussion around OSAT. This whole event is about the semiconductors. But let's kind of remind ourselves that semiconductor is one piece of the puzzle. There's a lot more to the supply chain. And semiconductor industry as such will be, or the semiconductors we are trying to build here, will not necessarily be something which you can capacitize for India consumption alone. So semiconductor will stand on its own, which means consumption in India as well as global. But we need to look at rest of the pieces of supply chain. I think Raghu talked about PCB. They are investing already. They have announced. So PCBs there, semiconductors are there, but there are a whole bunch of other popcorn parts, as I call them, because in manufacturing, unfortunately, you cannot make the product even if you have 9,999 part, if you don't have that one last part out of 10,000. So we need to look at the whole ecosystem of supply chain. So more encouragement is required for the inbound supply chain, as in other components as well, along with semiconductors.
Thanks, Satinder. Ravi, what's your ask?
I think from a material standpoint, it really depends on a combination of demand, product market fit, and factors of production locally. So ultimately, it has to be justifiable financially in a reasonable period of time. So whatever can be done to do that, I mean, we have an aggressive growth plan, so certainly open to it. But that has to be thought through very well. I think as the ecosystem develops, all these additional models will come into play. There's no doubt and question about that. It just needs sort of transparent communication between the value chain players. Yeah.
Thanks, Ravi, and really glad for all the ask and recommendation to the government. Thank you very much. Would you like to ask any questions from the audience?
Hey, good afternoon. Thank you all. It was a nice insight about the ESDM. So I come from a technology designer, same ESDM, but into more compute modules based on the processor. From my ask, since whatever the company, whether it is Apple or Tesla or whoever basically, so they design and then give it to us, and then end of the day, we are kind of owners, or if you say like, we got the baby, now we are the baby raisers, basically. Now, when I come to a net zero carbon, which is a global issue, and then e-waste is one of the key contribution of that, and the repair policies. So, since we are pushing these things to the market, how we are connected or responsible, or like how our customers, say it is OEMs like Apple or so, are bringing these control on e-waste. Yes, there are a lot of policies, but on ground, if you really say, just think each of us, how many power adapters we would have cycled or like thrown it away in last 10 years. So how is that we are controlling at last mile manufacturer or the key player in this cycle?
Very good question, by the way. I'll give a couple of comments and then, of course, hand over to you. ESG and sustainability actually is like influencing this market very, very heavily. There are two parts here. There's a big opportunity for us and some challenges as well. The opportunity is there that a lot of global companies, they want to move the sourcing to India only to suppliers who are green ready, right? Now, who can actually commit to delivering to their sustainability standards. And of course, India already has put up BRSR as a standard, and they're asking all companies in India, irrespective of whether it's electronic manufacturing or otherwise, to start complying to these norms. I'd like to invite comments from actual business leaders here. What your experience and comments on this?
Well, you used to run a business, so you can comment as well on this. No, I think, see, this industry, as Vinod said, has been at the forefront of environmental sustainability for a long time, very, very long time. Lead-free, all the other compliances there. I don't know how many compliances, we have to adhere to, and driven by many countries. And India, for instance, has taken a very, very strong position on this. Even though India's maybe still on a development cycle, we are, I think, in my mind, 30 years ahead in a way of adopting things. And all of those things are adopted here, either by domestic companies or multinationals. Now, the important part of this ecology is that these things start with a brand. The OEM starts this. And companies like that, who we are the last mile, I think you used I think it's the right word. We are the last mile deliverers, manufacturers. All of that is passed down to us. And we ensure that us and our suppliers are also managing, all of these things in accordance to the right things. But the truth is, it starts with the design. Certain brands and mobile phones have gotten rid of the adapters. Some of them have not. Right? So I think it starts with just how you productize, something. So, but I'll say that but there's a huge opportunity in recycling. I think the recycling bit in India is not advanced. the last 20 years since I've been back in India, we have tried to look at this area, but I think it's a huge opportunity for anybody to process, things. There are a few companies who have done really well, but I don't think there's enough. And as more core technologies comes here, I think this is going to be even more important. Yeah, I mean, I think, what is that, built to, right to repair, right? But it starts with the OEM. So the OEM has to say that, and it's a, right to repair is a design feature, right? It's really not in our purview, per se. But of course, we will support it. We'll ensure that the products are, compliant to right to repair and other things like that. So, but I think that is really more of a design feature in my opinion, so.
I have a question, Vinod. I think this may not be related to directly transforming Gujarat, but to understand that you guys are EMS and you have done this really well in the last maybe 20 years and so on. Two things I want to ask you. One is you guys assemble, so the PCBs, where India stands and the PCB manufacturing. Then second is the components which go into this assemblies, right? Actives and passives. Active I know. Passive side. On all this, because without this, right, the whole ecosystem, supply chain, all of you have imported, I don't know. So I just wanted to hear from the panel that where as a country India stands on PCB and components.
Okay, I'll give some fundamental stats that's visible. India today probably imports about 90% of that. So it's a huge import market at this point of time. And one of the things that government is definitely looking at is if you're looking at the semicon as the first one, then of course we are getting into the next level. And PCB and power supplies are the highest cost components in a lot of electronic equipments. So definitely the government is looking at how to incentivize more production of both PCB and power supplies in the country. Anything you would like to add from your experience, Raghu?
Yeah, just to take the first question. So, from our company standpoint, we have a windmill that we have set up so that from a generation standpoint that is taken care. And then, the usual like the solar power and stuff like that in our, 17-acre integrated manufacturing facility. Now come to Dr. Veerappan's question. From a cane standpoint, there are two projects. One is the OSAT and second is the bare board PCB. To that effect, MIT has cleared that, and we are looking at land where we could put it. It's an HDI capability with a large number of layers and stuff like that. So very soon in the next 1 month, you would see that announcements and stuff. We have a technology partner aligned and stuff. But that necessarily does not mean that we can still take care of the 90% import, doing a little bit of our bit along with the AT&S. I'm sure many more players would come into play.
Absolutely, very good, very well said, and it's almost similar. I mean, we should visualize the PCB industry like what mobile was, 5 years back, where we couldn't get to the scale, and PCB we should move to that scale over the next 5 years. Components as well, absolutely. Yeah. Okay. Thank you.
Thank you so much, sir. Thank you so much to all the panelists and moderator. If you have any more questions, then I'm sure we all can meet you throughout the day and ask and have a conversation with you personally. Now I would request Shri J.B. Vadar, sir, Executive Director, Gujarat Science City, to please come up on stage and felicitate all our panelists and moderators. So we'll start with Mr. Josh Folger, President, Zetwork. Mr. Raghu Panikar, CEO, Keynes Semicon. Mr. Satendra Singh, CEO, Sirma SGS. And Dr. Ravi Bhatkal, MD, McDermid Alpha. And finally, our moderator, Mr. Vinod Subramaniam, Vice President, Technology Cluster and Invest India. I would request all our speakers from this session to please come up on stage. We already have the session coordinator on stage and the team to come up on stage for a group picture. And with this, I'll make my favorite announcement for today. You guys can go for lunch. Everybody can have their lunch now. Thank you so much.